What's going on? What's going on? Okay. So I need to learn JavaScript, React, and Next.js, and a little TypeScript in 4 hours. I don't know if that's achievable by just grinding Codecademy, but that's the goal. I have the fundamentals of JavaScript, fundamentals of TypeScript, fundamentals of React, and then if there's time, I will be reading or taking Next.js's tutorial course where you build a website with their framework from scratch. So that last one is looking a little iffy. The thumbnail and title of this video might end up being a like a catfish, but we'll see. That's the goal. So I'm gonna jump in and start learning JavaScript. And this one, I've worked with JavaScript before, but I've never actually taken a course. Free trial. I thought this was free. Hold on. Did it not just say free? Am I missing something? Okay. What is JavaScript? Last year, millions of learners from our community started with JavaScript. Why? JavaScript is primarily known as the language of most modern web browsers, and its early quirks gave it a bit of a bad reputation. However, the language has continued to evolve and improve. JavaScript is a powerful, flexible, and fast programming language now being used for increasingly complex web development and beyond. Since JavaScript remains at the core of web development, it's often the first language learned by self-taught coders eager to learn and build. We're excited for we're excited for what you'll be able to build. I gotta wake up. Recenter. Okay. We're excited for what you'll be able to create with JavaScript Foundation you gain here. JavaScript powers the dynamic behavior on most websites, including this one. In this lesson, you will learn introductory coding concepts, including data types and built-in objects, essential knowledge for all aspiring developers. Make sure to take notes and pace yourself. This foundation will set you up for understanding the more complex concepts you'll encounter later. Thanks, Codecademy. Console. The console is a panel that displays important messages like errors for developers. Much of the work your computer does with our code is invisible to us by default. If we want to see things appear on our screen, we can print or log to our console directly. In JavaScript, the console keyword refers to an object, a collection of data and actions that we can use in our code. Keywords are words that are built into the JavaScript language, so the computer recognizes them and treats them specially. One action or method that is built into the console object is the .log method. When we write console.log, what we put inside the parentheses will get printed or logged to the console. It's going to be very useful for us to print values to the console so we can see the work that we're doing. Console.log 5. This example logs 5 to the console. The semicolon denotes the end of the line or statement. Although in JavaScript your code will usually run as intended without a semicolon, we recommend learning the habit of ending each statement with a semicolon so you never leave one out in the few instances when they're required. You'll see later on that we can use console.log to print different kinds of data. So here we're going to use console.log code in the editor to log your age to the console. We're going to go 25. Run your code when you are ready to see the results. Cool. On the next line, write another console log. So console.log is like the print, because I'm comparing it to Python, to print out a different number representing the number of weeks you've been programming. I guess this is more intended for beginners. I guess I've been programming for about 2 years, so I'll say 104 weeks. Oops, can only be numbers. Comments. So programming is often highly collaborative. In addition, our own code can quickly become difficult to understand when we return to it. Sometimes only an hour later. For these reasons, it's often useful to leave notes in our code for other developers or ourselves. As we write JavaScript, we can write comments in our code that the computer will ignore as our program runs. These comments exist just for human readers. Comments can explain what the code is doing, leave instructions for developers using the code, or add any other useful annotations. There are two types of code comments in JavaScript. A single line comment will comment out a single line and is denoted with 2 forward slashes preceding it. You can also use a single line comment to comment after a line of code. A multi-line comment will comment out multiple lines and is denoted with /* to begin the comment and */ to end the comment. So that's just like C++ comments. You can also use this syntax to comment something out in the middle of a line of code. So, yep, cool. Instructions. Let's practice adding some code comments. To the right, we've provided you with the beginning of the book Catch-22 by Joseph Heller. On line 1, write a single line comment that says opening line. Single line comments are great for adding context to your code. Multi-line comments are often best suited to prevent a block of code from running. However, both types of comments can be used for either purpose. Use a multi-line comment to comment out the rest of the code after the first console.log line. Only it was love at first sight should be logged to the console. Great. Data types. Data types are the classifications we give to the different kinds of data that we use in programming. In JavaScript, there are 8 fundamental data types. Number, any number including numbers with decimals 4, 8, 15, 16, 23.42. Big int, any number greater than 2 to the 53rd power minus 1, or less than negative 2 to the 53rd power minus 1, with n appended to the number. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or just a big number. String, any grouping of characters on your keyboard, letters, numbers, spaces, symbols, etc., surrounded by single quotes or double quotes, though we prefer single quotes. Some people like to think of string as a fancy word for text. Boolean, this data type only has 2 possible values, either true or false, without quotes. It's helpful to think of booleans as on and off switches, or as the answers to a yes or no question. Null, this data type represents the intentional absence of a value and is represented by the keyword null without quotes. Undefined, this data type is denoted by the keyword undefined without quotes. It also represents the absence of a value, though it has a different use than null. Undefined means that a given value does not exist. Symbol, a newer feature to the language. Symbols are unique identifiers used in more complex coding. No need to worry about these for now. And object, collections of related data. The first 7 of those types are considered primitive data types. They are the most basic data types in the language. Objects are more complex, and you'll learn much more about them as you progress through JavaScript. At first, A types may not seem like that many, but soon you'll observe the world opens with possibilities once you start leveraging each one. As you learn more about objects, you'll be able to create complex collections of data. But before we do that, let's get comfortable with strings and numbers. So console.log, location of Codecademy headquarters, 575 Broadway, New York City, console.log 40. In the example above, we first printed a string. Our string isn't just a single word, it includes both capital and lowercase letters, spaces, and punctuation. Next, we printed the number 40. Notice we did not use quotes. On line 1, log the string JavaScript to the console. Oops. On line 2, log the number 2011 to the console. On line 3, print, woohoo, I love Codecademy. Hashtag Codecademy. I was just thinking how much I love Codecademy though, I'm not gonna lie. Like, it's amazing that I can learn this for free. On line 4, print the number 20.49 to the console. Amazing. Arithmetic operators. Basic arithmetic often comes in handy when programming. An operator is a character that performs a task in our code. JavaScript has several built-in arithmetic operators that allow us to perform mathematical calculations on numbers. These include the following operators and their corresponding symbols: add, subtract, multiply, divide, remainder. The first 4 work how you might guess. Note that when we console log, the computer will evaluate the expression inside the parentheses and print that result to the console. If we wanted to print the characters 3 plus 4, we would wrap them in quotes and print them as a string. And then 11 modulo 3, 12 modulo 3, the remainder operator, sometimes called modulo, returns the number that remains after the right-hand number divides into the left-hand number as many times as it can evenly. 11 modulo 3 equals 2 because 3 fits into 11 3 times, leaving 2 as the remainder. Inside of a console.log at 3.5 to your age. Just naturally as a programmer, I think, okay, let me declare an age variable and then add 3.5 to it. It just feels like the clean way to do it, right? This is the age you'll be when we start sending people to live on Mars. Huh? Is that the case? On a new line, run another console.log. Inside the parentheses, take the current year and subtract 1969. So the current year is 2024. That would mean between 69 and 29 would be 60 years. So 60 minus 5 is 5, so 55. Oh, just do the math. Let the computer do the math. Why am I trying to flex? Create another console.log. Inside the parentheses, divide 65 by 240. Divide 65 by 240. Create one last console.log. Inside the parentheses, multiply 0.270 by 100. That's the percent of the sun that is made up of helium. Assuming we could stand on the sun, we'd all sound like chipmunks. String concatenation. Operators aren't just for numbers. When a plus operator is used on two strings, it appends the right string to the left string. So we see hi plus ya prints hiya. Whoa plus ah prints whoa. I love to plus code prints I love to code. This process of appending one string to another is called concatenation. Notice in the third example, we had to make sure to include a space at the end of the first string. The computer will join the strings exactly, so we needed to make sure to include the space we wanted between the two strings. So here we see front space, back, and the space over there. We see no space there, and we see a space added on its own. Just like with regular math, we can combine or chain our operations to get a final result. So 1 plus a comma plus 2 and a comma 3. Inside a console.log, concatenate the two strings hello and world. You should concatenate the two strings exactly without any additional characters. Got you, they want me to fail. We left off the space last time. Create a second console.log in which you concatenate the strings hello and world, but this time make sure to also include a space between the two words. Cool. Properties. When you introduce a new piece of data into a JavaScript program, the browser saves it as an instance of the data type. All data types have access to specific properties that are passed down to each instance. For access to specific properties that are, for example, each and every string instance has a property called length that stores the number of characters in that string. You can retrieve property information by appending the string with a period and the property name. So here we see hello.length will print 5. That's the number of characters in hello. The dot is another operator. We call it the dot operator. In the example above, we value the value saved. All right, I get it. Use dot length property to log the number of characters. Okay. Well, it already has these. That dot length. Cool. Methods. Remember that methods are actions we can perform. Data types have access to specific methods that allow us to handle instances of that data type. JavaScript provides a number of string methods. We call or use these methods to append by appending an instance with a period, the dot operator, the name of the method, opening and closing parentheses. Example string method name. Does that syntax look a little familiar? When we use console.log, we're calling the .log method on the console object. Let's see console.log and some real string methods in action. So this hello dot to uppercase printed all uppercase, and this hey dot starts with H prints true. Let's look at each of these lines above. On the first line, the to uppercase method is called on the string instance hello. The result is logged to the console. This method returns a string in all capital letters hello. On the second line, the dot starts with method is called on the string instance hey. This method also accepts the character H as an input or argument between the parentheses. Since the string hey does start with the letter H, the method returns the boolean true. Okay, so use the dot to uppercase method to log the string code academy to the console in all capital letters. To uppercase, and then in the second console.log statement in app.js, we have a string remove whitespace, which has spaces before and after the words remove whitespace. If we browse the JavaScript string documentation, we find several built-in methods, string methods that each accomplish a different goal. The one method that seems ideal for us is .trim. Use the method to remove the whitespace at the beginning and end of the string in the second console.log statement. So let's copy that and then do .trim. I think they want me to read the docs, but I don't got time for all that. So this is an assumption. Did you use the right method? Check the hint if you need help finding. How do we do this? You can, oh goodness. Damn it, that didn't work. Can I just maybe I don't need to pass in an argument. Okay, great. Cool. Built-in objects. In addition to console, there are other objects built into JavaScript. Down the line, you build your own objects, but for now, these built-in objects are full of useful functionality. For example, if you wanted to perform more complex mathematical operations than arithmetic, JavaScript has the built-in math object. The great thing about objects is that they have methods. Let's call the random method from the built-in math object. So console.log math.random puts a random number between 0 and 1. In the example above, we called the .random method by appending the object name with the .parameter, the name of the method, and opening and closing parentheses. This method returns a random number between 0 inclusive and 1 exclusive. To generate a random number between 0 and 50, we could multiply this result by 50 like so. Math.random times 50. The example above will likely evaluate to a decimal. To ensure the answer is a whole number, we can take advantage of another useful math method called math.floor. Math.floor takes a decimal number and rounds down to the nearest whole number. You can use math.floor to round down a random number like this. So math.random times 50. Oh, math.floor accepts math.random times 50. Okay. In this case, math.random generates a random number between 0 and 1. Yeah, we then multiply that number by 50, so now we have a number between 0 and 50. Then math.floor rounds the number down to the nearest whole number. If you wanted to see the number printed to the terminal, you would still need a console.log statement. Console.log math.floor math.random times 50 prints a random whole number between 0 and 50 to see all the properties, blah, 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 inside of a console. Console.log, create a random number with math.random. Multiply it by 100. Now use math.floor to make the output a whole number. So math.floor inside the console log, with the last step, blah blah, find a method on the JavaScript math object that returns the smallest integer greater than or equal to the decimal. Find a method on the JavaScript method that returns the smallest integer greater than or equal to a decimal number. Use this method with the number 4.38. Log the answer to the console. So we need the smallest integer greater than or equal to a decimal number. So if we said the decimal number was, I don't know, let's say 4.58, then we need the smallest integer greater than or equal to that. So anything less than what? Don't make me do this. I'm looking at the hint. Use the ceil method to calculate the smallest integer greater than or equal to 4.38. So forward 3.8. Probably did that wrong. It's not a function. Yeah, how do I do this? You're making me do this. Okay, fine. Fine, I'll read the docs. How dare you? Math.ceil. I forgot the math part. Returns the smallest integer greater than or equal to x. Okay. Cool. So use the ceil method, use the JavaScript documentation to find a method on the built-in number object that checks if a number is an integer. To find a method on the built-in number object that checks if a number is an integer. Oops. Checking if a number is an integer. Is integer, cool. So put the number 2017 in parentheses of the method. So number dot is integer 2017 console.log it. True. Cool. Review. Okay, no. Keep going. Keep pushing. Variables. In programming, a variable is a container for a value. You can think of variables as little containers for information that live in a computer's memory. Information stored in variables such as a username, account number, or even personalized greeting can then be found in memory. Variables also provide a way of labeling data with a descriptive name so our programs can be understood more clearly by the reader and ourselves. In short, variables label and store data in memory. There are only a few things you can do with variables. Create a variable with a descriptive name, store or update information stored in a variable, reference or get information stored in a variable. It is important to distinguish that variables are not values. They contain values and represent them with a name. Observe the diagram with the colored boxes. Each box represents variables. The values are represented by the content, and the name is represented with the label. In this lesson, we will cover how to use the var, let, and const keywords to create variables. When you're ready to start, go to the next exercise. Create a variable var. There were a lot of changes introduced in the ES6 version of JavaScript in 2015. One of the biggest changes was two new keywords, let and const, to create or declare variables. Prior to the ES6, programmers could only use the var keyword to declare variables. Let's consider the example above. Var, short for variable, is a JavaScript keyword that creates or declares a new variable. My name is the variable's name. Capitalizing in this way is a standard convention in JavaScript called camel casing. In camel casing, you group words into one. Okay. Equals is the assignment operator. Aria is the value assigned to the name variable. You can also say that the my name variable is initialized with the value of Aria. After the variable is declared, the string Aria is printed to the console by referencing the variable name. There are a few general rules for naming variables. Names cannot start with numbers. Variable names are case sensitive, and variable names cannot be the same as keywords. In the next exercise, we'll learn why ES6's let and const are the preferred variable keywords by many programmers. Because there is still a ton of code written prior to ES6, it's helpful to be familiar with the pre-ES6 var keyword. If you want to learn more about var and the quirks associated with it, check out the documentation. Declare a variable named my favorite food. Use the var keyword, so variable named favorite food equals pizza. Declare a variable named num slices. Num of slices equals 8. Oh yeah, do we need to use, we should be using semicolons. Under the num of slices variable, use console.log to print the value saved to favorite food. Console.log favorite food. Did I misspell something? On the following line, we need num slices. Cool. Create a variable, let. As mentioned in the previous exercise, the let keyword was introduced in ES6. The let keyword signals that the variable can be reassigned a different value. Take a look at the example. So again, it signals that the variable can be reassigned a different value. So let meal equals enchiladas, console.log meal, output enchiladas. Meal equals burrito, console.log meal, output burrito. Another concept that we should be aware of when using let and even var is that we can declare a variable without assigning the variable a value. In such a case, the variable will be automatically initialized with a value of undefined. So if we just do let price and we console.log price, the output is undefined. However, if we do price equals 350, then the output of console.log price will be 350. Notice in the example above, if we don't assign a value to a variable declared using the let keyword, it automatically has a value of undefined. We can reassign the value of the variable. So create a let variable called change me and set it equal to the boolean true. On the line after change me is declared, set the value of change me to be the boolean false. To check if change me was I didn't log it. Log the value saved to change me to the console. Dope. Create a variable const. The const keyword was also introduced in ES6 and is short for the word constant. Just like with var and let, you can store any value in a const variable. The way you could declare a const variable and assign a value to it follows the same structure as let and var. Take a look at the following example. Const my name, Gilberto, console.log my name, output Gilberto. However, a const variable cannot be reassigned because it is constant. If you try to reassign a const variable, you'll get a type error. Constant variables must be assigned a value when declared. If you try to declare a constant variable without a value, you'll get a syntax error. If you're trying to decide between which keyword to use, let or const, think about whether you'll need to reassign the variable later on. If you do need to reassign the variable, use let. Otherwise, use const. Create a constant variable named entree, const entree, and set it equal to the string enchiladas. Gotta remember to use semicolons. Just to check that you've saved the value of enchiladas to entree, log the value of entree to the console. So great, let's see what happens if you try to reassign a constant variable. Equals tacos. Can't type today for some reason. This code throws the following error when you run the code. Type error. After you clear this checkpoint, if you want to see another quirk of const in action, open the hint. Since our program stops running after encountering an error, we need to delete the line of code from the previous step. Now let's test what happens when you try to declare a const variable without a value. So delete that, and then const testing. Now we get a syntax error, missing initializer and const declaration. If you read this through this error, you'll see that it's related to syntax. You need to initialize a const with a variable value. Mathematical assignment operators. Let's consider how we can use variables and math operators to calculate new values and assign them to a variable. Check out the example below. Let w equals 4, w equals w plus 1, console.log w output 5. In the example above, we created the variable w with the number 4 assigned to it. The following line, w equals w plus 1, increases the value of w from 4 to 5. Another way we could have reassigned w after performing some mathematical operation on it is to use built-in mathematical assignment operators. We could rewrite the code above to be let w equals 4, w plus 1 equals 1, console.log w. In the second example, we use the plus equals assignment operator to reassign w. We're performing the mathematical operation of the first operator, plus, using the number to the right, then reassign w to the computed value. We also have access to other mathematical assignment operators. Okay, cool. Let's practice using these. Use the plus equals mathematical assignment operator to increase the value stored in level up by 5. So we have level up equals 10. And then we're going to use these here. So level up plus equals 5. Use this. Okay, so power level minus equals 100. Multiply me times equals 11, and then quarter me divide equals 4. Dopeness. The increment and decrement operator. Other mathematical assignment operators include the increment operator plus plus and decrement operator minus minus. The increment operator will increase the value of the variable by 1. The decrement operator will decrease the value of the variable by 1. For example, let a equals 10, a plus plus, console.log a, output 11. Let b equals 20, b minus minus, console.log b, output 19. Just like the previous mathematical assignment operators, the variable's value is updated and assigned as the new value of that variable. Using the increment operator, increase the value of gained dollar. Gained dollar plus plus. Using the decrement operator, decrease the value of lost dollar. Lost dollar minus minus. String concatenation with variables. In previous exercises, we assigned strings to variables. Now let's go over how to connect or concatenate strings in variables. The plus operator can be used to combine two string values, even if those values are being stored in variables. Let my pet equals armadillo, console.log I own a pet, plus my pet plus period. Output I own a pet armadillo. In the example above, we assign the value armadillo to the my pet variable. On the second line, the plus operator is used to combine three strings. I own a pet, the value saved to my pet, and period. We log the result of this concatenation to the console as I own a pet armadillo, period. Create a variable named favorite animal and set it equal to your favorite animal. Oops. Use console.log to print my favorite animal to the console. Use string concatenation so that animal is replaced with the value of your favorite animal variable. Okay, so console.log animal. Beautiful, beautiful, beautiful. String interpolation. In the ES6 version of JavaScript, we can insert or interpolate variables into strings using template literals. Check out the following example where a template literal is used to log strings together. So here we have const my pet armadillo, console.log I own a pet, $, curly braces my pet, and curly brace, period. And this outputs I own a pet armadillo. Notice that a template literal is wrapped by backticks. Backticks. Here, you see that? This key is usually located on the top of the keyboard, right here, left of the 1 key. Inside the template literal, you'll see a placeholder, $, curly braces my pet, and curly brace. The value of my pet is inserted into the template literal. When we interpolate I own a pet, $, curly brace my pet, the output we print is the string I own a pet armadillo. One of the biggest benefits to using template literals is the readability of the code. Using template literals, you can more easily tell what the new string will be. You also don't have to worry about escaping double quotes or single quotes. Create a variable named my name and assign it to your name. What did I do wrong? Oh, need them quotes. Create a variable named my city and assign it your favorite city's name. Let my city. You already know. Use a single template literal to interpolate your variables into the sentence below. Use console.log to print your sentence to the console in the following format. So my name is shift $, curly brace. My name is my name. Favorite city is my city. Yes, sir. Awesome. Type of operator. While writing code, it can be useful to keep track of the data types of the variables in your program. If you need to check the data type of a variable's value, you can use the type of operator. The type of operator checks the value to its right and returns or passes back a string of the data type. So here we see const unknown 1 equals foo. Console.log type of unknown 1 will output string because unknown 1 is a string. Const unknown 2 equals 10. Console.log type of unknown 2 will output number because unknown 2 has a type of number. Const unknown 3 equals true. Console.log type of unknown 3 will output boolean because unknown 3 is a boolean. Let's break down the first example. Since the value unknown 1 is foo, a string type of unknown will return string. Use console.log to print the type of new variable. So new variable is a string there. So if we console.log type of new variable. Dang it. We get this string. Great. Now let's check what happens if we reassign the variable. Below the console.log statement, reassign new variable to 1. Since you assign this new value to new variable, it has a new type. On the line below your reassignment, use console.log to print type of new variable again. Let's copy that. Okay, dopeness. Kelvin weather. Deep in his mountainside meteorology lab, the mad scientist Kelvin has mastered weather prediction. Recently, Kelvin began publishing his weather forecast on his website. However, there's a problem. All of his forecasts describe the temperature in Kelvin. With our knowledge of JavaScript, let's convert Kelvin to Celsius, then to Fahrenheit. Somebody just like in a lab coming up with weather experiments and determining how to quantify the weather with his own name is silly but hilarious. For example, 283K converts to 10 degrees Celsius, which converts to 50 degrees Fahrenheit. If you get stuck during this project or would like to see an experienced developer work through it, click Get Unstuck. No, we're not getting stuck, not today. The forecast today is 283 Kelvin. To start, create a variable named Kelvin and set it equal to 293. Let Kelvin equals 293. Write a comment above that. Write a comment above that explains this line of code. Set today's temp forecast in Kelvin. Celsius is similar to Kelvin. The only difference is that Celsius is 273 degrees less than Kelvin. Let's convert Kelvin to Celsius by subtracting 273 from the Kelvin variable. Store the result in another variable named Celsius. Oh, maybe I won't get the points if I don't specifically have this lowercase, so I'll change that. And now we need to convert Kelvin to Celsius. Store the variable named Celsius. Let Celsius equals Kelvin minus 273. Store it in Kelvin. Write a comment above that explains this code. Convert Kelvin. Okay. Done that. Use this equation to calculate Fahrenheit. Then store the answer in a variable named Fahrenheit. So, and we're going to want to Fahrenheit. And that happens because we do let Fahrenheit equals Celsius. What is it? Celsius times 9 divided by 5 plus 32. In the next step, we will round the number, save to Fahrenheit, choose the variable type that allows you to change its value. Write code. When you convert from Celsius to Fahrenheit, you often get a decimal number. Use the .floor method from the built-in math object to round down the Fahrenheit temperature. Save the result to the Fahrenheit variable. Fahrenheit equals math .floor Fahrenheit. Okay, did all this. Oh yeah, well I didn't do that. Round Fahrenheit down. And then console.log and the string. So console.log and string interpolation to log the temperature in Fahrenheit to the console as follows. So the temperature is temperature degrees Fahrenheit. Put this in backticks. And then, oops, what'd I do? Okay, whatever, I'll just type it. I don't know why that just did that, it's annoying. So the temperature is $ curly brace Fahrenheit degrees Fahrenheit semicolon. Run your program to see the results. Temperature is 68 degrees Fahrenheit. If you want to check your work, open the hint. Yes, sir. By using variables, your program should work for any Kelvin temperature. Just change the value of Kelvin and run the program again. What's 0 Kelvin in Fahrenheit? Let's see, 0 Kelvin. Negative 460. Amazing. Great work. Kelvin can now publish his forecasts in Celsius and in Fahrenheit. If you'd like extra practice, try this. Nah, I'm good. But it's just an extra conversion to the Newton scale, and then rounding down using the same floor method, and then using console.log with string interpolation. So all the principles that we know. So dogs mature at a faster rate than human beings. We often say a dog's age can be calculated in dog years to account for their growth compared to a human of the same age. In some ways, we could say time moves quickly for dogs. 8 years in a human's life equates to 45 years in a dog's life. How old would you be if you were a dog? Here's how you convert your age from human years to dog years. The first 2 years of a dog's life count as 10.5 dog years each. Each year following equates to 4 dog years. Before you start doing the math in your head, let a computer take care of it. With your knowledge of math operators and variables, use JavaScript to convert your human age into dog years. If you get stuck during this project or would like to see an experienced developer go through it, we got this. Create a variable named myAge and set it equal to your age as a number. Write a comment that explains this line of code. Set my age. Okay, create a variable named early years. Let early years. And save the value 2 to it. Write a comment. Set early years. Note the value saved to this variable will change. Use the multiplication assignment operator to multiply the value saved to early years by 10.5 and reassign it to early years. Multiplication assignment operator, so early years equals or times equals 10.5. Since we already accounted for the first 2 years, take the myAge variable and subtract 2 from it. myAge minus equals 2. Set the result equal to a variable named later years. Okay, so we'll just do later years equals myAge minus 2. And write a code that explains this line of code. Subtracting the early years from myAge. Okay, so we did that. Just taking my row, subtract 2 later years. Okay. Oh yeah, we got to do that. Multiply the later years variable by 4 to calculate. This is annoying me. I just got to do that. Multiply the later years variable by 4 to calculate the number of dog years accounted for by your later years. Use the multiplication assignment operator to multiply and assign in one step. Write a comment that explains this line of code. So, multiply later years by 4 for dog years. So, later years times equals 4. If you'd like to check your work at this point, print early years and later years to the console. Later years, semicolon, semicolon. Cool. If you'd like to, did that. Add early years and later years together and store that in a variable named myAge in dog years. So, plus later years, myAge in dog years, age in dog years. So that, write a line of code. Calculate age in dog years. Years. Let's use a string method next. Write your name as a string, call its built-in method, dot to lowercase, and store the result in a variable called my name. So let my name equals, so write your name as a string, call its built-in method, dot to lowercase, and store the result in a variable called my name. So it's just, I think it's geo dot to lowercase. Might be wrong. The to lowercase method returns a string with all. Write a comment that explains this line of code. Make my name lowercase. Write a console.log statement that displays your name and age in dog years. Use string interpolation to display the value in the following sentence. Can I copy it this time? No, you won't. Won't let me. Okay, console.log. We use backticks for string interpolation. So my name is $ curly brace. Oh, how'd I get there? My name is $ curly brace. My name. I am $ curly brace. My age. Years old in human years, which is $ curly brace. My age in dog years. Years old in dog years. Replace name with my name. Yep. Write a comment. Print statement. My name is Geo. I'm 25 years old in human years, which is 113 years old in dog years. Great work. You can convert any human age to dog years. Try changing my age and see what happens. If you like extra practice, try writing this project without the times equals operators. So if I make myself 250, we get 1013. Amazing. Okay, what's next? Which of the following is an example of a single line comment? It's this one. Will the following code print to the console? num10, num times equals 3, so 30. What is the correct way to call a string's built-in method? So use the string .to uppercase. What is the outcome of the following code snippet? Console.log hello world. Hello world is printed to the console. That's printed. Hello world is printed to the console with single quotation mark. This one. Which of the following code snippets would cause an error? Let food equals chicken. Food equals sushi. Const food equals chicken. Food equals sushi. It's that one. Const food. Let food. Yeah. What are variables used for in JavaScript? For changing a value's data type, for changing language settings, for storing holding data. What is the outcome of this statement? Console.log hi.length. Hi is printed to the console. 3 is printed to the console. What is the correct way to declare a new variable that you can change? Let my name equals Sloan. What is string concatenation? When you join strings together, when you change a variable's value, when you assign a string to a variable, when you join strings together. What is string interpolation? Changing value, joining multiple strings together. You use template literals to embed variables into strings. Printing string, yeah. Great. Okay. This is a long read. JavaScript versions ES6 and before. Ever heard of the term ES6 and wondered what it's about? Read this article to read and find out. You might have seen the term ES6 or JavaScript ES6 and wondered what it actually means. We'll wonder no further because we're going to dive into what ES6 is and how it relates to JavaScript. First, let's bring in some history. JavaScript was introduced in 1995 by the company Netscape Communications as a scripting language for web developers and programmers to interact with web pages. The next year, Netscape submitted JavaScript to a standards development organization called ECMA International to create standards for a scripting language, a type of programming language. In 1997, ECMA International released ECMA 262, which sets standards for the first version of a scripting language called ECMAScript, shortened to ES. These new ECMAScript standards provided rules for the architecture of JavaScript features. As new programming paradigms emerged and developers sought new features, newer versions of ECMAScript provided a basis for consistency between new and old JavaScript versions. To fully distinguish the difference between JavaScript and ECMAScript, if you want to create an app or program, you can use JavaScript. If you want to create a new scripting language, you can follow the guidelines in ECMAScript. So when you see ES6 or JavaScript ES6, it means that the version of JavaScript is following the specifications in the 6th edition of ECMAScript. You might also see ES 2015 instead of ES6, but both terminologies are referring to the same 6th edition of ECMAScript that was released in 2015. Take a look at the timeline below to see how JavaScript has evolved over the years. It started with Netscape browser was launched, and now ES 2018 was released with REST and spread properties, asynchronous iteration, promise.finally, and additions to regular expressions. Now you may be asking, what makes an update in 2015 still relevant today when there are more recent updates like ES7 and ES8? Well, despite the release of newer versions, ES6 is actually the biggest update made to ECMAScript since the first edition released in 1997. Some developers even refer to ES6 as modern JavaScript because all of the major additions. There were also so many great features added to help JavaScript developers that include new keywords like letting const to declare variables, new function syntax using arrow functions, creation of classes, parameters with default values, promises for asynchronous actions, and many more. Up-to-date browsers now support most of the ES6 features, which allow developers to take advantage of these new additions. ES6 ultimately allows programmers to save time and write more concise code. Take, for example, pre-ES6 syntax for functional expressions. So here we would have var greeting equals. So greeting is a function, and this function is a console.log of hello world. With ES6 arrow functions, we can transform the expression above into const greeting equals an empty parentheses, and this is console.log. So that means now when we call greeting with parentheses, it's really doing a console.log of hello world, I think, because right, var greeting was a function, and so now in this case, because like a lot of other languages use curly braces to define functions, and so it does feel a little bit more intuitive to me because I've seen these arrows and been like, what really is happening there? But all it is a function definition. Interesting. So we could just as easily do, let's say, console.log 1 plus 2 if we want to create a function that just outputs 2. So function add ones. I don't know. Let's just say const make 2 equals, and then parentheses, and then this arrow console.log 1 plus 1 or something like that. However, arrow functions are not just simply syntactical rewrites. As with other ES6 features, there are other underlying benefits and trade-offs to consider. Nonetheless, there has been a strong adoption of ES6 in the development community. Benefits such as new ES6 syntax make it easier to utilize a popular programming paradigm, object-oriented programming. With this change, developers in other languages who are used to OOP have a smoother transition into learning and using JavaScript. Another reason for the popularity of ES6 is correlated with the usage of ES6 in popular frameworks like React. So, if you want to learn the newest tools and frameworks, you'll have to pick up ES6 along the way. This being said, we shouldn't disregard legacy code, i.e. older versions of JavaScript. In fact, there's still many projects that are built and maintained with legacy code. If you want the ability and freedom to work on any sort of JavaScript project, you should familiarize yourself with pre-ES6 and ES6 JavaScript syntax. But don't worry, we cover both pre-ES6 and ES6 in our JavaScript course. Check it out to become a rock star at JavaScript basics and learn fundamental programming skills. Great. Make the most of your Codecademy membership. No, thank you. I'll continue being here and not making the most of it because I don't even have a membership anymore, I don't think. Or I guess I have an account, but not a membership. So what are conditional statements? In life, we make decisions based on circumstances. Think of an everyday decision as mundane as falling asleep. If we are tired, we go to bed. Otherwise, we wake up and start our day. These if-else decisions can be modeled in code by creating conditional statements. A conditional statement checks a specific condition and checks a specific condition and performs a task based on the condition. In this lesson, we will explore how programs make decisions by evaluating conditions and introduce logic into our code. We'll be covering the following concepts: if, else if, and else statements, comparison operators, logical operators, truthy versus falsy values, ternary operators, switch statement. So if you're ready to learn these concepts, go to the next lesson. Else, read over the concepts, observe the diagram, and prepare yourself for this lesson. So if I'm sleepy, then sleep in. Else, start your day. If statement. We often perform a task based on a condition. For example, if the weather is nice today, then we go outside. If the alarm clock rings, then we'll shut it off. If we're tired, then we'll go to sleep. In programming, we can also perform a task based on a condition using an if statement. So if true, console.log, this message will print. Notice in the example above, we have an if statement. The if statement is composed of the if keyword followed by a set of parentheses, which is followed by a code block or block statement indicated by a set of curly braces. Inside the parentheses, a condition is provided that evaluates to true or false. If the condition evaluates to true, the code inside the curly braces runs or executes. If the condition is false, the block won't execute. Let's make an if statement. Using the let keyword, declare a variable named sale, assign the value true to it. So let sale equals true. Now create an if statement, provide the if statement a condition of sale. So if sale, inside the code block of the if statement, console.log, the string time to buy. Right, we put the parentheses. Oh, parentheses go there. Cool. So I said parentheses, I meant semicolon. Notice that the code inside the if statement ran since time to buy was logged to the console below the sale variable declaration, but before the if statement, reassign sale to false. So sale, goodness, sale equals false. But run your code and observe what happens. We'll be changing this behavior in the next exercise, so nothing happens. In the previous exercise, we used an if statement that checked a condition to decide whether or not to run a block of code. In many cases, we'll have to code. What is this? Please complete. Sorry. In the previous exercise, we used an if statement that checked a condition to decide whether or not to run a block of code. In many cases, we'll have code we want to run if our condition evaluates to false. If we wanted to add some default behavior to the if statement, we can add an else statement to run a block of code when the condition evaluates to false. Take a look at the inclusion of an else statement. So if false console.log, the code in this block will not run. Else console.log, but the code in this block will. Print, but the code in this block will. An else statement must be paired with an if statement, and together they are referred to as an if-else statement. In the example above, the else statement uses the else keyword following the code block of an if statement, has a code block that is wrapped by a set of curly braces. The code inside the else statement code block will execute when the if statement's condition evaluates to false. If else statements allow us to automate solutions to yes or no questions, also known as binary decisions. Add an else statement to the existing if statement inside the code block of the else statement console.log, the string time to wait for a sale. So else awesome. Comparison operators. When writing conditional statements, sometimes we need to use different types of operators to compare values. These operators are called comparison operators. Here's a list of some handy comparison operators and their syntax. Less than, greater than, less than or equal to, greater than or equal to, is not equal to. Comparison operators compare the value on the left with the value on the right. For instance, 10 less than 12 evaluates to true. It can be helpful to think of comparison statements as questions. When the answer is yes, the statement evaluates to true. When the answer is no, the statement evaluates to false. The code above would be asking, is 10 less than 12? Yes. So 10 is less than 12 evaluates to true. We can also use comparison operators on different data types like strings. Apples is equal to oranges is false. In the example above, we're using the identity operator, which is 3 equal signs, to check if the string apples is the same as the string oranges. Since the two strings are not the same, the comparison statement evaluates to false. All comparison statements evaluate to either true or false and are made up of two values that will be compared, an operator that separates the values and compares them accordingly. Let's practice using these comparison operators. Using let, create a variable named hunger level and set it equal to 7. Write an if-else statement using a comparison operator. The condition should check if hunger level is greater than 7. If so, the conditional statement should log time to eat. Otherwise, it should log we can eat later. After you press run, play around with the condition by tweaking the comparison of hunger level and by using different operators such as all those. What did I do wrong? Oh, hunger level. We can eat later. Logical operators. Working with conditionals means that we will be using booleans, true or false values. In JavaScript, there are operators that work with boolean values known as logical operators. We can use logical operators to add more sophisticated logic to our conditionals. There are 3 logical operators: the AND operator and ampersand ampersand, the OR operator, pipe pipe, the NOT operator, otherwise known as the bang operator, exclamation mark. When we use the ampersand ampersand AND operator, we are checking that 2 things are true. If stoplight is equal to green and pedestrians is equal to 0, console.log go, else console.log stop. When using the AND operator, both conditions must evaluate to true for the entire condition to evaluate to true and execute. Otherwise, if either condition is false, the AND condition will evaluate to false and the else block will execute. If we only care about either condition being true, we can use the OR operator. If day is equal to Saturday or the day is equal to Sunday, console.log enjoy the weekend, else console.log do some work. When using the OR operator, only one of the conditions must evaluate to true. For the overall statement to be true, okay, cool, I understand this. The NOT operator reverses or negates the value of a boolean. So let excited equals true, console.log not excited will print false because it's reversing, negating the value of the boolean. So if let sleepy equals false, console.log not sleepy will print true. Essentially, the NOT operator will either take a true value and pass back false, or will take a false value and pass back true. Logical operators are often used in conditional statements to add another layer of logic to your code. In main.js, there are 2 variables, mood and tiredness level. Let's create an if-else statement that checks if mood is sleepy and tiredness level is greater than 8. So if checks if mood is sleepy, mood is equal to sleepy, and tiredness level is equal to 8. Oh, it's greater than 8. So if mood equals sleepy and tiredness level is greater than 8, both conditions evaluate to true, console.log this string time to sleep. Otherwise, we should console.log not bedtime yet. After you press run, play around with the OR operator and the NOT operator. So not bedtime yet, but if our mood is sleepy or tiredness level is above 8, then it is time to sleep. So, and then we could mess around with these parentheses, see how these work in JavaScript. So tiredness level is greater than 8, which is not true. So this tiredness level greater than 8 should come out to false. So if not tiredness level, then this is backwards logic, but regardless, it runs, whatever. Truthy and falsy. Let's consider how non-Boolean data types like strings or numbers are evaluated when checked inside a condition. Sometimes you'll want to check if a variable exists, and you won't necessarily want it to equate a specific value. You'll only check to see if the variable has been assigned a value. Here's an example. So let my variable equals I exist. If my variable exists at all, console.log my variable, else console.log the variable does not exist. The code block in the if statement will run because my variable has a truthy value, even though the value of my variable is not explicitly the value true. When used in a Boolean or conditional context, it evaluates to true because it has been assigned a non-falsy value. So which values are falsy or evaluate to false when checked as a condition? The list of falsy values includes 0, the empty strings, null, undefined, nan, or not a number. Here's an example with numbers. Let number of apples equal 0. If number of apples, console.log let us eat apples, else console.log no apples left, print no apples left. The condition evaluates to false because the value of the number of apples is 0. Since 0 is a falsy value, the code block in the else statement will run. Change the value of word count so that it is truthy. This value should still be a number. So word count, let's just make it 1. After you make this change and run your code, great. You started your work, should log to the console. Change the value of favorite phrase so that it is still a string but falsy. So we'll just make that an empty string. After you make this change and run your code, this string is definitely empty, should log to the console. Truthy and falsy assignment. Truthy and falsy evaluations open a world of shorthand possibilities. Say you have a website and want to take a user's username to make a personalized greeting. Sometimes the user does not have an account, making the username variable falsy. The code below checks if username is defined and assigns a default string if it is not. So let username equals an empty string. Let default name. So default name will also have a falsy value. So if username, then default name equals username. Else default name equals stranger. Console.log default name. If you combine your knowledge of logical operators, you can use a shorthand for the above code. In a Boolean condition, JavaScript assigns the truthy value to a variable if you use the OR operator in your assignment. So let username equals empty string, let default name equals username or stranger. Console.log default name will print stranger. Because or statements check the left-hand condition first. The variable default name will be assigned the actual value of username if it is truthy, and will be assigned the value of stranger if username is falsy. This concept is also referred to as short-circuit evaluation. Let's use short-circuit evaluation to assign a variable to writing utensil. Do not edit tool yet, or return to tool in the next step. Assign to writing utensil the value of tool, and if tool is falsy, assign a value of pen. So writing utensil, the value of tool, let writing utensil tool, or if it's falsy, assign it a value of pen. Notice that text, the pen is mightier than the sword, log to the console, which means the value of writing utensil is pen. What if we reassign the value of tool to marker? Let's see what happens. The marker is mightier than the sword. Haha. Ternary operator. In the spirit of using shorthand syntax, we can use a ternary operator to simplify an if-else statement. Take a look at the if-else statement example. So let is nighttime equals true. If is nighttime, console.log turn off the lights. Else console.log turn off the lights. Oh, sorry. Yeah, it's nighttime. It's true. Turn on the lights. Else turn off the lights. We can use a ternary operator to perform the same functionality. Is nighttime, question mark, console.log, turn on the lights. Console.log, turn off the lights. In the example above, the condition is nighttime is provided before the question mark. The two expressions follow the question mark and are separated by a colon. If the condition evaluates to true, the first expression executes. If the condition evaluates to false, the second expression executes. Like if-else statements, ternary operators can be used for conditions which evaluate to true or false. Refactor or edit the first if-else block to use a ternary operator. So this if-else block can be refactored to is locked, question mark. You can do console.log. You will need a key to open the door, colon, console.log. You will not need a key to open the door. What did I do wrong? Variable, question mark, console.log this, colon, console.log that. You will not need a key, missing, refactor the second if-else block to use a ternary operator. So this if-else, so just is correct. If that is true, console.log correct. Otherwise, we will be console.logging incorrect. Refactor the third if-else block to use a ternary operator. So if favorite food equals love that, so favorite phrase equals love that, question mark. If so, we will console.log I love that. Otherwise, we will be console.logging I don't love that, and run it. Cool. Else if statements. We can add more conditions to our if-else with an else-if statement. The else-if statement allows for more than two possible outcomes. You can add as many else-if statements as you'd like to make more complex conditionals. The else-if statement always comes after the if statement and before the else statement. The else-if statement also takes a condition. Let's take a look at the syntax. Let stoplight equals yellow. If stoplight is equal to red, console.log stop. Else if stoplight is equal to yellow, console.log slow down. Else if stoplight is equal to green, console.log go. Else if stoplight just else, console.log, caution, unknown. The else if statement allows you to have multiple possible outcomes. If, else statements are read from top to bottom. So the first condition that evaluates the true from the top to the bottom is the block that gets executed. In the example above, since stoplight is equal to red evaluates to false, and stoplight is equal to yellow evaluates to true, the code inside the first else if statement is executed. The rest of the conditions are not evaluated. If none of the conditions evaluate to true, then the code in the else statement would have executed. Let's create a program that keeps track of the way the environment changes with the seasons. Write a conditional statement to make this happen. In main.js, there is already an if-else statement in place. Let's add an else-if statement that checks if season is equal to winter. Inside the code block of the else-if statement, add a console.log that prints the string, it's winter, everything is covered in snow. Make sure that the structure uses if, else if, and else. So we have let season is equal to summer, if season is equal to spring, console.log, it's spring, the trees are budding. Okay, so save that for last. We'll do else if else if season is equal to winter, then we're gonna console.log it's winter. What was the thing? Everything is covered in snow. Make sure that the structure uses if, else if, and else. Bring this else back up here, and we're Gucci. Run it. Invalid season. Add another else if statement that checks if season is equal to fall. Inside the code block of the else if statement you just created, add a console.log that prints the string, it's fall, leaves are falling. Let's do this in order. So if else if season is equal to fall, console.log it's fall, leaves are falling. And then bring this back up here. Season is equal to fall. What did I do wrong? Did you check if season is equal to fall in the second else if statement? I did, right? What did I do wrong? So if season is equal to spring, console.log it's spring, the trees are falling. Else if season is equal to fall, console.log it's fall, leaves are falling. Else if season is equal to winter, console.log everything's covered in snow. So if some condition, code, else if another condition, code, else if, what did I do wrong? Is it maybe you want me to go in a different order? That's going to be really annoying if that's the case. It's really stupid. Okay, add a final else if statement that checks if season is equal to summer. Inside the code block of the else if statement you just created, add a console.log that prints the string it's sunny and warm because it's summer. I shall do that. Else if season is equal to summer, console.log it's summer. Oh, it's sunny and warm because it is summer. I'll take this. The switch keyword. Else if statements are a great tool if we need to check multiple conditions. In programming, we often find ourselves needing to check multiple values and handling each of them differently. For example, let grocery item equal papaya. If grocery item is equal to tomato, console.log tomatoes are 0.49. Else if grocery item is equal to papaya, console.log papayas are 129, else console.log invalid item. In the code above, we have a series of conditions checking for a value that matches a grocery item variable. Our code works fine, but imagine if we needed to check 100 different values. Having to write that many else if statements sounds like a pain. A switch statement provides an alternative syntax that is easier to read and write. A switch statement looks like this. Switch grocery item, case tomato, console.log tomatoes are that. Break, case lime, console.log limes are 149. Break, case papaya, console.log papayas are 129. Break, default, console.log invalid item. Break. We will print papayas are 129 because grocery item is equal to papaya, which matches this case. The switch keyword indicates, okay, I got you. Let's write a switch statement to decide what medal to award an athlete. So let athlete final position equals first place. Athlete final position is already defined at the top of main.js. Start writing a switch statement with athlete final position as its expression. So switch athlete final position case let's resume with does it I think so it wants me to write a full switch statement. Okay, so I guess we'll just do first place console.log winner break, and then we'll do a default console.log loser, and then break. Inside the switch statement, add 3 cases. The first case checks for the value first place. If the expression's value matches the value of the case, then console.log the string, you get the gold medal. Second case, console.log, you get the silver medal. If you ain't first, you last. Third place. Damn it. Third place. You get the bronze medal. Break them. Ooh, ooh. Just waking up in the morning. Focus. Now add a default statement at the end of the switch that uses console.log to print no medal awarded. It's much kinder than just calling them a loser with an exclamation mark. Nice. If athlete final position does not equal any value of our cases, the string no medal award is logged to the console. Remember to add the break keyword. Review. Way to go. Way to freaking go. What's up next? What are we doing? Magic 8 ball. What time is it? Okay. How good am I doing for time? That's actually my time that I allotted to JavaScript. So here's what I'm gonna do. I'm gonna finish this Magic 8 ball, and let me just look at the syllabus real quick. Honestly, I think it's time to move on. Like, that's my time. I feel good about it. I mean, I have an understanding generally now of conditionals and yeah, okay. We gotta move. Gotta keep moving. So, about to move on to TypeScript. I'm gonna get a little bit more coffee. Be right back. Is this still going? That'll be tragedy. Stop sharing. Okay, cool. pushing. I'm really glad I'm doing this, honestly. The main reason I'm doing this, right, is because I need to get a user interface for a server I built in Python. I need to get the user interface built and deployed in like a week. So given that, I'm planning on just breezing through this stuff so I could just jump into Next.js with an actual understanding, and then probably have a bunch of help from like Copilot or something. But it just needs to function. I need to be able to implement user authentication and connection to some HTTP endpoints. Those are the main two functionalities, and then just making it look pretty. So it shouldn't be overly complex, because it's stuff I've done as part of a team before, but this is my first time doing it and like myself, and so I gotta learn these fundamentals, because I just look at the code and I'm like, what even is this? When I'm looking at the, a React boilerplate, I'm just like, what is happening? Okay. Feeling good, feeling great. No buckets. Okay. Put this right there. Learn TypeScript fundamentals. Apply the JavaScript syntax to TypeScript's type system to give your code more structure. Invented in 1995, JavaScript was designed as a small scripting language for simple web pages and browsers. It wasn't until 1999 that JavaScript was capable of supporting the kinds of dynamic web pages we see today, and using JavaScript that way wasn't common practice until 2005. To serve its original use case, JavaScript was designed to be very flexible and easy to use for small applications. These features make JavaScript a great first language to learn, but they also make it less than ideal for building larger scale applications with hundreds or even thousands of files. Stricter programming languages will inform the developer when they change one area of code in a way that will break other areas. JavaScript will not, which often leads to unexpected behavior at runtime. To address these shortcomings, Microsoft developed TypeScript and released publicly in 2012 to blend the flexibility of JavaScript with the advantages of a stricter language. TypeScript is a programming language that adds types to JavaScript. It allows us to write JavaScript with a set of tools called a type system that can spot potential bugs in, clarify the structure of, and help refactor our code. In addition, TypeScript added newer JavaScript language features such as arrow functions and classes years before they were added to JavaScript officially. Today, TypeScript is one of the most loved languages in the world. From open source projects such as Angular and Webpack to large-scale development at Amazon and Google, we use it at Code Academy. What is TypeScript? So now that we know why TypeScript exists, let's talk about how we use it. First, we write TypeScript code in files with the extension .ts. Next, we run our code through the TypeScript transpiler. The transpiler will check that the code adheres to TypeScript standards, and it will display errors when it does not. If the TypeScript code can be converted into working JavaScript, the transpiler will output a JavaScript version of the file .js. TypeScript code is a superset of JavaScript code. It has all of the features of traditional JavaScript, but adds some new features. Given this TypeScript code as input, let first name equals Anders. The TypeScript transpiler would output this JavaScript code, let first name equals Anders. That's right, they're the same. TypeScript code generally looks roughly the same as the equivalent JavaScript. What we'll learn throughout this lesson and course is the real joy of using TypeScript, that it helps us understand more about our code and particularly discover bugs. In this exercise and throughout the lesson, we'll provide you with a bash terminal to execute your code. We'll be working with both TypeScript files with the extension .ts, and JavaScript files with the extension .js. The TypeScript transcompiler can be used on the command line by running the tsc command. This will create an equivalent .js file in the same directory, as well as surface any errors found by the TypeScript transcompiler. So again, the TypeScript transcompiler can be used on the command line by running the tsc command. This will create an equivalent JS file in the same directory, as well as surface any errors found by the TypeScript transcompiler. Run the TypeScript transcompiler using the tsc command. Great work. You've now created an index.js file. You can confirm this by running the ls command in your terminal. So we have index.js, index.ts, and ts.config.json. Run the results in JavaScript file with the node command, node index.js. I hate when I do that. Hello world, awesome. Type inferences. JavaScript allows us to assign any value to a variable. That makes it very flexible to use, which can be good for getting started quickly in coding. In practice, variables that are assigned values of multiple types throughout a program can be very confusing or lead to bugs. One of the first things we'll discover with TypeScript is that when we declare a variable with an initial value, the variable can never be reassigned a value of a different data type. This is an example of type inference. Everywhere in our program, TypeScript expects the data type of the variable to match the type of the value initially assigned to it at declaration. TypeScript recognizes JavaScript's built-in primitive data types, Boolean, number, null, string, undefined. If we try to reassign a variable to a value of a different type, TypeScript will surface an error. So let order equals first. If we try to make order equals 1, running TypeScript above will result in the following error being surfaced in the terminal: type number is not assignable to type string. TypeScript's type system is telling us that order is expected to be the primitive type string, but we're trying to assign it a value of type number. That's not allowed. Variables can only be assigned the types expected by the type system. We can fix this compliant by changing the new value to be the expected string type. So let order equals first, order equals a string 1. Let's practice. Our code has a bug. When we run our JavaScript code in index.js, node index.js, it brings not a number years instead of the expected 28 years. Use the tsc command to run the index.ts file and surface any type errors. So tsc. So index.ts line 5.3, error type string is not assignable to type number. So here we have if aged is true, then real age equals 4 years, but we cannot make this string because real age needs to be a number. Okay, so it looks like we're assigning the wrong type of data to real age. Change the assigned value of real age to be the expected value with the correct type. The assigned value of real age to be the expected value with the correct type. So I guess we'll make it. Is that what it meant? Cool. And now we can run it. Oh, index.js. Oh, I need to compile it again, right? Yeah. TypeScript compile. And now I can do node index.js 28 years. Cool. Type shapes. Because TypeScript knows what types our objects are, it also knows what shapes our objects adhere to. An object's shape describes, among other things, what properties and methods it does or doesn't contain. The built-in types in JavaScript each have known properties and methods that always exist. All strings, for example, are known to have a .length property and a .toLowercase method. So o.length is 2, my.toLowercase is my. TypeScript's tsc command will let you know if your code tries to access properties and methods that don't exist. So if we try to do my.toLowercase, property toLowercase does not exist on type my. Did you mean .toLowercase? Oh, because see, we didn't capitalize that C. Through this knowledge of type shapes, TypeScript helps us quickly locate bugs in our code. Let's try it. More bugs. We already compiled our index.tsx or .ts file. Try running index.js by entering node index.js into the bash shell. The code throws an error instead of printing the following expected output. So let first name equals Muriel, console.log first name dot to uppercase, console.log first name dot length. We didn't spell that right, so we're gonna get some errors here. So node index.js, look first name dot to uppercase, type error dot to uppercase is not a function. Because we didn't capitalize this. So we're compiled, try running it in bash shell, the code throws an error. Use TypeScript's tsc command to see type errors in the index. So index 3.2, property to uppercase does not exist on type string. Did you mean to uppercase? We did. Let's fix it then, because that's probably what they're telling us to do next. Surfacing and using the image guide, you fixed it up. And then here we go. What's next? Index 5.23, length. Did you mean length? Yeah, we did. Length is declared here. Found 2 errors. And so now the TypeScript compiler just serves using the error message guide. You fix both errors in the index. So fix the errors and now confirm that everything is now working properly. Run TypeScript compile again to compile your TypeScript code. and then run node index.js to run the JavaScript program. Muriel 7. Dope. Take a sip. Any. There are some places where TypeScript will not try to infer what type something is. Generally, when a variable is declared without being assigned an initial value, in situations where it isn't able to infer a type, TypeScript will consider a variable to be of type any. Variables of type any can be assigned to any value, and TypeScript won't give an error if they're reassigned to a different type later on. Let on or off equals 1, on or off equals false. In the code above, we declared the variable on or off without an initial value. TypeScript considers it to be of type any, and therefore doesn't produce an error when we change the variable's assignment from the number value to a Boolean type. It didn't let that sink in. My mind was elsewhere. So there are some places where TypeScript will not try to infer what type something is, generally when a variable is declared without being assigned an initial value. In situations where it isn't able to infer a type, TypeScript will consider a variable to be of type any. Variables of type any can be assigned to any value, and TypeScript won't give an error if they are reassigned to a different type later on. So in this case, this will not give us an error because on or off has a type of any. In the code above, we declared the variable on or off without any initial value. TypeScript considers it to be of type any and therefore doesn't produce an error. We change the variable's assignment from a number value to a Boolean value. Declare a variable with a let name guess without assigning it a value. We're thinking of a color. Take a guess at what it is. On a new line, assign this color as a string to the guess variable. So guess equals blue. Now we're thinking of a number. Take a guess at what it is. On a new line, reassign the guess variable to your number guess. Guess equals to your number guess. Wait, what? Oh, so I guess 2. Now let's verify that TypeScript has no problem with the assignments of our guess variable. Run tsc, TypeScript compile, notice the lack of error messages. Cool. Variable type annotations. In some situations, we'd like to declare a variable without an initial value while still ensuring that it will only ever be assigned values of a certain type. If it left as any, TypeScript won't be able to protect us from accidentally assigning a variable to an incorrect type that could break our code. We can tell TypeScript what type something is or will be by using a type annotation. Variables can have type annotations, also known as type declarations, added just after their names. We provide a type annotation by appending a variable with a colon and the type, number, string, or any. So let must be a string, must be a string equals cat dog, must be a string equals 1337, error type number is not assignable to type string. In the code above, we explicitly declare must be a string to be of type string without assigning it an initial value. This enables us to assign it the value cat dog without complaint, but when we later attempt to assign it a numerical value, TypeScript will give us an error message telling us that a number is being improperly assigned to a variable of type string. We're becoming familiar with how useful type annotations can be. Some developers may find that type annotations make the code wordy or hard for others to understand. However, they get automatically removed when compiled to JavaScript. The phone number variable is meant to be able to store non-numeric characters. For compatibility with international phone numbers, add a type declaration to inform TypeScript that it should be a string. So let phone number be a string. Use the tsc command to check the file for type errors. Error, type number is not assignable to type string. So here we use math.random, 0.5 phone number. That's a string, else phone number, that's not a string, that's a number. So error looks like one of the values assigned to phone number isn't valid. Fix that value per TypeScript's type complaints. And notice that the randomness introduced by math.random has no impact on whether TypeScript finds the type error. So if we make that, is that what it wants to do? Fix that value per TypeScript's type complaints. I believe that's that. So if math.random is greater than 0.5, this is just saying there's a 50-50 shot whether it's going to be this phone number or this phone number. That's why this numerical value has no mapping to like the exact number that gets assigned to phone number. So run it, and let's just check that because I want to. And it compiles. Cool. Review. All right, you've taken some great first steps. Amazing. Feeling good, feeling great. The tsconfig.json file. Let's explore what the tsconfig.json file is for. TypeScript features are extremely useful. For one, it allows us to add types to regular JavaScript code. It also checks for syntax errors even before runtime. It even provides tooltips that show you why some code might throw an error. There are so many great features that come by default. Even with all these great features, TypeScript recognizes the need for flexibility. Sometimes you don't want all the default rules that TypeScript is trying to enforce, and that's fine. That's one reason why providing a tsconfig.json file is useful. Additionally, you get perks like telling the TypeScript compiler what files to run on and more. So let's explore what this file looks like and how it helps. Sample tsconfig.json and breakdown. The tsconfig.json file is always placed in the root of your project, and you can customize what rules you want the TypeScript compiler to enforce. Here's the tsconfig file we provide in every single exercise and project in our Learn TypeScript course. Compiler options, target ES 2017, module, common.js, strict null checks, true, include, ****.ts. In the JSON, there are several properties. Compiler options, which is a nested object that contains the rules for the TypeScript compiler to enforce. Target, the value ES 2017, means the project will be using the 2017 version of ECMAScript standards for JavaScript. Module, this project will be using common.js syntax to import and export modules. Strict null checks, variables can only have null or undefined values if they are explicitly assigned those values. Include, that determines what files the compiler applies the rules to. In this case, ****.ts means the compiler should check every single file that has a .ts extension. We chose these rules because we wanted to give you an idea of what rules to enforce and still allow your creativity to shine. For your own projects, you can set these rules to your own preferences. The tsconfig.json file is great for both individual work and team projects because it allows everyone to be on the same page about how to write their code. Usage. Another neat addition is that by including a tsconfig.json file, you can now use the command tsc without any arguments in your terminal. The compiler will automatically recognize from your tsconfig.json file what specific files to run on. You can also still provide specific files like tscfilename.ts if that's the only file you want the compiler to check. Wrap up. Check out TypeScript's compiler option documentation for even more information. Happy coding, and when in doubt, type it out. Okay, I don't need to do these. So, next steps, you've successfully completed Learn TypeScript Fundamentals. What's next? Congratulations. You got the fundamentals. You learned to apply JavaScript syntax, TypeScript system. Learning isn't over. So I could get into all these, but honestly, I think at this point, I'm running ahead of time, which is a great thing. I'm just gonna jump into React and see if I crash and burn, and if I do, maybe I need to walk back. But I'm gonna have to find out the hard way. So I'm gonna get a little bit more coffee and then I'm gonna jump in. Good, we good? Yeah, we're good. All right, get into it. Why React? React.js is a JavaScript library developed by engineers at Facebook. Here are just a few of the reasons why people choose to program with React. React is fast. Apps made in React can handle complex updates and still feel quick and responsive. React is modular. Instead of writing large, dense files of code, you can write many smaller, reusable files. React's modularity can be a beautiful solution to JavaScript's maintainability problems. React is scalable. Large programs that display a lot of changing data. Move this closer to my face. Cool. React is scalable. Large programs that display a lot of changing data are where React performs best. React is flexible. You can use React for interesting projects that have nothing to do with making a web app. People are still figuring out React's potential. There's room to explore. React is popular. While this reason has admittedly little to do with React's quality, the truth is that understanding React will make you more employable. If you are new to React, then this course is for you. No prior React knowledge is expected. We will still We will start at the very beginning and move slowly. By the end, you'll be ready to program in React with a real understanding of what you're doing. Amazing. Exactly what I need. So, hello world. Take a look at the following line of code. What kind of weird hybrid code is that? Is it JavaScript, HTML, or something else? It seems like it must be a JavaScript instance since it starts with cont and ends with a semicolon. If you tried to run that in an HTML file, it wouldn't work. However, the code also contains h1 hello world, closing h1, which looks exactly like HTML. That part wouldn't work if you tried to run it in a JavaScript file. What's going on? Copy the following line into app.js. So const h1 equals h1 hello world, close h1, click run when you're finished. What's gonna happen? Okay, it happened. The mystery revealed. Take another look at the line of code that you wrote. Does this code belong in a JavaScript file, an HTML file, or somewhere else? The answer is a JavaScript file. Despite what it looks like, your code doesn't actually contain any HTML at all. The part that looks like HTML, h1 hello world h1, is something called JSX. Click next to learn about JSX. What is JSX? JSX is a syntax extension for JavaScript. It was written to be used with React. JSX code looks a lot like HTML. What does syntax extension mean? In this case, it means that JSX is not valid JavaScript. Web browsers can't read it. If a JavaScript file contains JSX code, then that file will have to be compiled. This means that before the file reaches a web browser, a JSX compiler will translate any JSX into regular JavaScript. Codecademy servers already have a JSX compiler installed, so you don't have to worry about that for now. Eventually, we'll walk through how to set up a JSX compiler on your personal computer. Cool. A basic unit of JSX is called a JSX element. Here's an example of a JSX element. h1 hello world, close h1. This JSX element looks exactly like HTML. The only noticeable difference is that you would find it in a JavaScript file instead of an HTML file. In app.js, write a JSX p element containing the text hello world. Use the example code above as a guide. So just, I don't think they want me to add it to a variable. I think they just want me to write it. So p hello world, lowercase w, close p. Great. JSX elements and their surroundings. JSX elements are treated as JavaScript expressions. They can go anywhere that JavaScript expressions can go. This means that a JSX element can be saved in a variable, passed to a function, stored in an object or array, you name it. Here's an example of a JSX element being saved in a variable. Const navbar equals nav, I am a navbar. Here's an example of several JSX elements being stored in an object. Const my team equals center, list item Benzo Wally, power forward, list item Rasha Loa, small forward, list item Tayshaun Dasmodo, shooting guard, list item Colmar Cumberbatch, point guard, list item Femi Bilon. Those names are crazy. Create a JSX article element. Save it in a variable named myArticle. So const my article equals article, I don't know, article, this is an article. Is that right? What's wrong? Did you set the variable myArticle equal to article? Oh, it didn't want anything in it. Oh, I think I'm doing too much. Yeah, I'm doing too much. Doing way too much. Attributes in JSX. JSX elements can have attributes, just like how HTML elements can. A JSX attribute is written using HTML-like syntax, a name followed by an equal sign followed by a value. The value should be wrapped in quotes like this. So my attribute name equals my attribute value. Here are some JSX elements with attributes. So we have an anchor with a href equals http www.example.com, and the text is welcome to the web. And anchor const title equals h1, id is title, introduction to React.js, part 1, and h1. A single JSX element can have many attributes, just like in HTML. So const panda is equal to image with a source of images /panda.jpg, an alt value of panda, a width of 500 pixels, and a height of 500 pixels. So just to read this over again. So JSX elements can have attributes just like how HTML elements can. A JSX attribute is written using HTML-like syntax, a name followed by an equal sign followed by a value. The value should be wrapped in quotes like this. So my attribute name is my attribute value. JSX elements with attributes. So in this case, this href is considered an attribute in JSX, and in this case, this ID is considered an attribute. This source is an attribute. Alt is a panda, so it's a single JSX element can have many attributes. So yeah, it's just like HTML. Declare a constant name P1. Set P1 equal to a JSX P element containing the text foo. P foo. Oops. On the next line, declare a constant name P2. Set P2 equal to another JSX element or P element containing the word bar. Give the P stored in P1 an ID attribute of large. Give the P stored in P2 an ID attribute of small. Cool. Nested JSX. You can nest JSX elements inside of other JSX elements, just like in HTML. Here's an example of a JSX H1 element nested inside of a JSX A element. So anchor href equals HTTPS, and inside of this anchor is an H1 with click me. Okay, to make this more readable, you can use HTML style line breaks and indentation. So I have this anchor with this this HTTPS for the href, and then inside of that is a header, and then we end the anchor. If a JSX expression takes up more than one line, then you must wrap the multi-line JSX expression in parentheses. This looks strange at first, but you get used to it. So since this is all taking up more than one line, we wrap it in parentheses, but it's the same idea. Nested JSX expressions can be saved as variables, passed to functions, etc., just like non-nested JSX expressions can. Here's an example of a nested JSX expression being saved as a variable. So const the example, and we have it wrapped in parentheses, and then we have this anchor. Inside the anchor is click me, and then we end the anchor. And if you're unfamiliar with HTML, I would definitely recommend just taking the Codecademy HTML course, but in anchor, just make something a link essentially. Declare a new variable named myDiv. Set myDiv equal to a JSX div element. So const myDiv. Set myDiv equal to a JSX div element. So div. Wrap the div in parentheses and use indentation and line breaks like in the example. So we're gonna put that down there, indent it, put a parentheses up there, and the parentheses down there, then indent that, or whatever, line break, and then in between the div tags nest an H1 element, so H1 containing the text hello world, and the H1. I don't know how they want me to do this exactly, but we'll do it just like they did it, in case that's what they want. And then add this semicolon here, and we're good. Are we good? No, we're not. Did you declare a div element within the parentheses with only a nested? Okay, so maybe they didn't want me to do that actually. It looks like I messed up. Okay, no, that's not the issue. So const myDiv is equal to div h1 hello world, close h1, and div, and end it. Declare a new variable named myDiv. Set myDiv equal to a JSX div element. Wrap the div in parentheses and use indentation and line breaks. Like in the examples, in between the div tags nest an H1 containing the text. Oh, I added this period unnecessarily. That's the issue. Silly. JSX outer elements. There's a rule that we haven't mentioned. A JSX expression must have exactly one outermost element. In other words, this code will work. Const paragraphs equals div ID equals I am the outermost element, p I am a paragraph, p I too am a paragraph, end div. But this code will not work. Const paragraphs, paragraph I'm a paragraph, paragraph I too am a paragraph. The first opening tag and the final closing tag of a JSX expression must belong to the same JSX element. It's easy to forget about this rule and end up with errors that are tough to diagnose. If you notice that a JSX expression has multiple outer elements, the solution is usually simple. Wrap the JSX expression in a div element. Your friend's blog is down. He's asked you to fix it. You immediately diagnose the problem, a JSX expression with multiple outer elements. Repair your friend's broken code by wrapping the JSX in a div element. So here we have const blog equals an image, a header, welcome to Dan's blog, the article, wow, I had the tastiest sandwich today. I literally almost freaked out, and this is broken because it's not wrapped. Oh my goodness, why'd I do that? Go forward. Does this work? Am I hitting the wrong thing? Okay. And then we add a div around it. Will it work? Will it work? Will it work? Yes, it will. Rendering JSX. You've learned how to write JSX elements. Now it's time to learn how to render them. To render a JSX expression means to make it appear on screen. The following code will render a JSX expression. Const container equals document.getElementById app. Const root equals create root container. Root.render h1 hello world. Following code will render a JSX expression. So we have this HTML tag here, and root renders it. And of course, root creates a root from a container. And we have this container document.getElementById app. I'm a little confused about what all that means, but we'll figure it out. Starting on line 5, carefully copy the above code into the code editor. So we're going to carefully copy that into the code editor on line 5. We'll go over how it works in the next exercise. Will it compile? Will it run? Yes, it will. All right, I gotta use the bathroom real quick, so bio break. One, two, 1, 2. It's gonna be a tragedy the day I turn that down and forget to turn it back up. That is gonna be a tragedy, and I'd just be talking for hours. No audio. That would be terrible. Okay. So this code renders this JSX expression. We're gonna go over it in the next exercise, but essentially all we need to know now is this hello world gets built. We imported React from React, imported create root from React DOM client. We have this container. It's a document.getElementById app. Interesting. Okay, let's figure out how this is happening. So let's examine the code that you just wrote in the last exercise. Const container equals document.getElementById app. Const root equals create root container root.render h1 hello world. Before we get started, it is essential to understand that React relies on two things to render: what content to render and where to place the content. With that in mind, let's look at the first line. Const container equals document.getElementById app. This line uses the document object, which represents our web page. Okay, so this const container is document. Uses the getElementById method of document to get the element object representing the HTML element with the passed in ID app. Again, uses the getElementById method of document object to get the element object representing the HTML element with the passed in ID app, and it stores the element in container. In the next line, const root equals create root container. We use create root from the React DOM client library, which creates a React root from container and stores it in root. Root can be used to render a JSX expression. This is the where to place the content part of React rendering. Finally, the last line, root.render h1 hello world close h1, uses the render method of root to render the content passed in as an argument. Here we pass an h1 element, which displays hello world. This is the what content to render part of React rendering. Below the import statements, define a constant called container and set its values equal to the expression below, document.getElementById container. So, const container, creating a container variable really, and we're assigning it to a document, and the document that this will be gotten by element by ID, and what we're passing it is app. So I think this is essentially just telling it, hey, our container, this is gonna be an app, and it's pulling all this from these imports up here. Run it. Oops, what'd I do? Did you set containers value equal to document.get? Oh, my fault. My fault. Sorry, guys. Yeah, it's container, not app. Next, define a constant called root and set its value equal to the expression below. So, const root equals create. So it takes container and creates a root from it. Finally, paste the following expression to render some content. So root.render hello world. Nice. Passing a variable to render. In the previous exercise, we saw how we can create a React root using create root and use its render method to create JSX. The render method's argument doesn't need to be JSX, but it should evaluate to a JSX expression. So again, in the previous exercise, we saw how we can create a React root using create root and use its render method to render JSX. The render method's argument doesn't need to be JSX, but it should evaluate to a JSX expression. The argument could also be a variable, so long as that variable evaluates to a JSX expression. In this example, we save a JSX expression as a variable named to-do list. We then pass to-do list as the argument of render. So here we see const to-do list is an ordered list, list item learn React, list item become a developer, and the ordered list, and then const container equals document.getElementById app, const root equals create root container, and then root.render our to-do list. On line 7, declare a variable named myList. Set myList equal to a JSX unordered list element. Wrap your unordered list tag in parentheses. Did that. Add several list item elements in between your unordered list tags. One, two, 3. What did I do wrong? Oh. Use line breaks and indentations similar to the above example. Oh, I think this does need that though. At the bottom of the file, use root and call its render method with my list as an argument. So root dot render render my list. Use root and call its render 1, 2, 3. Feel free to use the example code as a guide. Awesome. So the virtual DOM. One special thing about a React Roots render method is that it only updates DOM elements that have changed. What is DOM? Oops, didn't mean to do that. What exactly did it say? One special thing about a React Roots render method is that it only updates DOM elements that have changed. In this context, DOM stands for Document Object Model. It's a programming interface for web documents. It represents the structure of a document like a web page and allows a program to manipulate the document's structure, style, and content. When you're working with React, the document object model is important because React creates a virtual document object model to improve performance. When the state of an object changes, React only updates the changed document object model elements rather than updating all of the document object model elements. This is what the sentence "it only updates document object model elements that have changed" is referring to. This selective updating is one of the reasons why React is popular for building dynamic web applications. It helps to make the application faster and more efficient. Great, thank you. Okay, so one special thing about React Roots render method is that it only updates DOM elements that have changed. That means that if you render the exact same thing twice in a row, the second render will do nothing. So here we see const hello equals h1 hello world. This will add hello world to the screen. So root.render hello document.getElement by ID app. So root.render hello. So it's rendering hello, and document.getElement by ID app, and the document is app. This won't do anything at all. If we do a root render hello document.getElement by ID app, this is significant. Only updating the necessary document object model elements is a large part of what makes React so successful. This is accomplished using React's virtual document object model. Review. Congratulations, you've learned to create and render JSX elements. This is the first step towards becoming fluent in React. In this lesson, we learned that React is a modular, scalable, flexible, and popular front-end framework. JSX is a syntax extension for JavaScript, which allows us to treat HTML as expressions that can be stored in variables, object arrays, and more. JSX elements can have attributes and be nested within each other, just like in HTML. JSX must have exactly one outer element, and other elements can be nested inside. Again, must have exactly one outer element, and other elements can be nested inside. Create root from React Document Object Manager client can be used to create a React root at the specified document object model. Document object model, yeah. So create root from React Document Object Model / client can be used to create a React root at the specified document object model element. A React Roots render method can be used to render JSX on the screen. A React Roots render method only updates document object model elements that have changed using the virtual document object model. As you continue to learn more about React, you'll learn some powerful things you can do with JSX, some common JSX issues, and how to avoid them. Great. React, the virtual document object model. Learn how React's virtual document object model prevents wasteful document object model manipulation. The problem: document object model manipulation is the heart of the modern interactive web. Unfortunately, it is a lot slower than most JavaScript operations. This slowness is made worse by the fact that most JavaScript frameworks update the document object model much more than they have to. As an example, let's say that you have a list that contains 10 items. You check off the first item. Most JavaScript frameworks would rebuild the entire list. That's 10 times more work than necessary. Only one item changed, but the remaining 9 get rebuilt exactly how they were before. Rebuilding a list is no big deal to a web browser, but modern websites can use huge amounts of document object manipulation. Inefficient updating has become a serious problem. To address this problem, the people at React popularized something called the virtual document object model. The virtual document object model here is a refresher of what happens behind the scenes in the virtual document object model. I guess, do I need to watch this? Okay, I guess I'll watch it, right? But that means I'm gonna have to let you guys hear it. So, first of all, I'm gonna shut off this really nice noise. I love that. Okay. Turn this up. Listen to this. So calming, right? Okay, let's see what this is about. Play it super fast.
Hi everyone, this is Michael from Codecademy, and I am excited to be discussing virtual DOMs with you today. As a refresher, the DOM, which stands for Document Object Model, is a representation of a web page created by and stored in a user's browser. The browser takes the site's HTML, transforms it into a DOM, and then paints the DOM to the user's screen, making the site visible to the user. The DOM is stored as a tree-like structure, where each HTML element corresponds to a node in the tree. Let's look at how the browser would take the HTML file and translate it into a DOM tree. In this example, we've got a body tag containing a header that says things to learn, and an unnoted list of programming languages our user wants to learn. We've also included a button for each list item that allows our user to check off the item and remove it from the list. The DOM tree will render as follows. The top node will represent the body tag. The body node will have two child nodes underneath it, the h1 node and the ul node. Now, text is also represented as a node, so the h1 node will have a child text node, and the ul node will have 3 outline node children, which each have a text node child and a button node child, which each have a text node child of their own. Now, you don't need to fret about all the details about DOMs created. All you need to know is the DOM is a tree of nodes representing a web page. It is then painted by the browser for users to see. In this example, let's say a user clicks the remove button next to the remove list item. We want to remove this list item in response. That node and all the nodes underneath it will be removed from the DOM. Whenever a browser detects a change to the DOM, it repaints the entire page using the new version of the DOM. But wait, do we really need to repaint the whole page? Didn't only one part of the site change? For example, why do we have to repaint the header if nothing about it is different? Comparing two DOMs to determine what parts have changed is time consuming. As a result, it's actually faster for browsers to simply repaint the entire page whenever a user interacts with the site, instead of determining what, if anything, has changed. However, what if there was a fast way to make these comparisons? That's where the virtual DOM comes in. Some front-end frameworks like Vue and React create their own representation of the DOM as a JavaScript object. Whenever a change is going to be made to the DOM, the framework instead makes a copy of this JavaScript object, makes a change to that copy, and compares the two JavaScript objects to see what has changed. It then informs the browser of these changes, and only those parts of the DOM are repainted. Making changes to JavaScript objects and comparing them is far faster than trying to do the same with DOMs. As a result, using JavaScript objects, we can quickly determine what to repaint in a way we couldn't by just relying on the browser. Since this copy of the DOM is stored in memory as a JavaScript object, it's called a virtual DOM. Using a virtual DOM allows frameworks to identify when a user interaction doesn't require a repaint at all, when it repaints only parts of the state that have changed, and groups together repaints, so that one user interaction doesn't require the entire page to be repainted multiple times. In summary, repainting a page takes time, and modern web apps constantly have tons of small changes. Attempting to repaint the whole page for each one makes sites slow and buggy. Using a virtual DOM allows us to only repaint what is necessary, greatly improving page performance and creating even more amazing user experiences.
Okay, makes sense. Makes sense. So, where were we? Okay. So, that's the refresher of what happens behind the scenes in the virtual DOM. Pretty much just deals with the nodes in the tree that need to be edited. In React, for every DOM object, there is a corresponding virtual DOM object. A virtual DOM object is a representation of a DOM document object model object, like a lightweight copy. A virtual document object model object has the same properties as a real document object model object, but it lacks the real thing's power to directly change what's on the screen. Manipulating the DOM is slow. Manipulating the virtual DOM is much faster because nothing gets drawn on screen. Think of manipulating the virtual DOM as editing a blueprint, as opposed to moving rooms in an actual house. How it helps. When you render a JSX element, every single virtual document object model object gets updated. This sounds incredibly inefficient, but the cost is insignificant because the virtual DOM can update so quickly. Once the virtual DOM has been updated, then React compares the virtual DOM with a virtual DOM snapshot that was taken right before the update. By comparing the new virtual DOM with a pre-update version, React figures out exactly which virtual DOM objects have changed. This process is called diffing. Once React knows which virtual DOM objects have changed, then React updates those objects, and only those objects, on the real document object model. In our example from earlier, React would be smart enough to rebuild your one checked off list item and leave the rest of your list alone. This makes a big difference. React can update only the necessary parts of the document object model. React's reputation for performance comes largely from this innovation. In summary, here's what happens when you try to update the document object model in React. The entire virtual document object model gets updated. The virtual document object model gets compared to what it looked like before you updated it. React figures out which objects have changed. The changed objects and the changed objects only get updated on the real document object model. Changes on the real document object model cause the screen to change. Cool stuff. Definitely cool stuff. Okay. Class versus class name. This lesson will cover more advanced JSX. You'll learn some powerful tricks and some common errors to avoid. Grammar in JSX is mostly the same as in HTML, but there are subtle differences to watch out for. The most frequent of these involves the word class. In HTML, it's common to use class as an attribute name. H1 class, big, title. In JSX, you can't use the word class. You have to use class name instead, so H1 class name, big, title. This is because JSX gets translated into JavaScript, and class is a reserved word in JavaScript. When JSX is rendered, JSX class name attributes are automatically rendered as class attributes. On line 7, declare a new constant named myDiv. Set myDiv equal to a JSX div element. So on line 7, new constant myDiv equals a div element. In between the div tags, write I am a big div. Give your div element the following attribute. So class name equals big. Underneath your div element, call root.render with myDiv as an argument. If your rendered div element has a class of big, then it should look big in the browser. I'm a big div. Self-closing tags. Another common JSX error involves self-closing tags. What's a self-closing tag? Most HTML elements have two tags, an opening tag, div, and a closing tag, closing div. However, some HTML elements, such as image and input, use only one tag. The tag that belongs to a single tag element isn't an opening tag or a closing tag. It's a self-closing tag. When you write a self-closing tag in HTML, it is optional to include a / immediately before the final angle bracket. So, fine in HTML with a slash, also fine without the slash. But in JSX, you have to include the slash. If you write a self-closing tag in JSX and forget the slash, you will raise an error. So, break, closing slash is fine in JSX, just break is not fine at all in JSX. So in app.js, fix the broken JSX by adding slashes to all of the self-closing tags. So here, these line breaks need a closing tag. This image also needs a closing tag, and these are good. Article, yep, cool. JavaScript in your JSX, in your JavaScript. So far, we focus on writing JSX expressions. It's similar to writing bits of HTML, but inside of a JavaScript file. In this lesson, we're going to add something new, regular JavaScript, written inside of a JSX expression, written inside of a JavaScript file. Starting on line 7, carefully write the following code. Write line 7, root.render h1 2 plus 3 close h1. What do you think will appear in the browser? Well, before this I would have thought that would come out as a string of just 2 plus 3, but now it seems like it's probably going to add them together and create 5. Which is interesting. Oh, so no, yeah. It is 2 plus 3. The fact that this got highlighted made me kind of confused. Curly braces in JSX. The code in the last exercise didn't behave as one might expect. Instead of adding 2 and 3, it printed out 2 plus 3 as a string of text. Why? This happened because 2 plus 3 is located in between h1 and closing h1 tags. Any code in between the tags of a JSX element will be read as JSX, not as regular JavaScript. JSX doesn't add numbers, it reads them as text, just like HTML. You need a way to write code that says, even though I am located in between JSX tags, treat me like ordinary JavaScript and not like JSX. You can do this by wrapping your code in curly braces. Add a pair of curly braces to the code from the last exercise so that your JSX expression looks like this. So, curly brace there, curly brace there. Oops, not that. Everything inside of the curly braces will be treated as regular JavaScript. Pretty cool stuff. Oh, cool. 20 digits of pi in JSX. You can now inject regular JavaScript into JSX expressions. This will be extremely useful. In the code editor, you can see a JSX expression that displays the first 20 digits of pi. Study the expression and notice, so we have const pi, a div, a header, so pi, y'all, and then a paragraph element, so math.py.tofixed. So this is just calling pi from the math library, and we're calling the tofixed method and setting it to 20 digits, and the paragraph and the div, and then react dom.render. We're rendering this, running all this, and then document.getElement by ID app. So the code is written in a JavaScript file. By default, it will all be treated as regular JavaScript. Find div on line 5. From there, go through the div. The code will be treated as JSX. So all of this, JSX. Find math. From there, up through 20, the code will be treated as regular JavaScript again because it's within the curly braces. The curly braces themselves won't be treated as JSX or as JavaScript. They are markers that signal the beginning and end of a JavaScript injection into JSX, similar to the quotation marks that signal the boundaries of a string. Open app.js. Declare a new variable named math. Set math equal to a JSX h1 element. Put the following expression inside of the h1. 2 plus 3 equals 2 plus 3. Okay. And run it. We can see all that up there, right? Oh no, because it's not rendering. We didn't set it to render. At the bottom of the file, call root.render. For root.render's argument, pass math. Now it'll render. Okay. As you probably expected, the equation was displayed as a string. Insert a pair of curly braces inside the h1 tags so that the browser displays 2 plus 3 equals 5. So wrap these in curly braces. And now we'll get 2 plus 3 equals 5. Variables in JSX. When you inject JavaScript into JSX, that JavaScript is part of the same environment as the rest of the JavaScript in your file. That means that you can access variables while inside of a JSX expression, even if those variables were declared outside of the JSX code block. Again, when you inject JavaScript into JSX, that JavaScript is part of the same environment as the rest of the JavaScript in your file. That means that you can access variables while inside of a JSX expression, even if those variables were declared outside of the JSX code block. So here we have a declared variable, constant name, Gerdo. Access your variable inside of a JSX expression, const greeting equals p hello name, and we can change name to anything, and it'll render inside when we eventually render, but it'll be inside that p. Replace root.render's argument with a JSX h1. So root.render h1, oops, h1, h1. Using curly braces, set the h1 tag's inner text equal to the best string. The text was accessed through a JavaScript variable. Cool. Variable attributes in JSX. When writing JSX, it's common to use variables to set attributes. Here's an example of how that might work. Use a variable to set the height and width attributes. So const side length equals 200 pixels. Const panda equals image, source images slash panda.jpg, alt panda, height side length, width side length. It's common to do this. Notice how in this example, the images attributes each get their own line. This can make your code more readable if you have a lot of attributes for one element. Okay, again, notice how in this example, the images attributes each get their own line. This can make your code more readable if you have a lot of attributes for one element. Object properties are also often used to set attributes. So here we see const pix is equal to panda is this link, owl is this link, and owlcat is this link. If we do const panda equals an image with a source of pix.panda and an alt of lazy panda, we have const owl equals an image with pix.owl and an alt of an unimpressed owl, and const owlcat equals image source is pix.owlcat and alt is a ghastly abomination. How dare you? On line 9, declare a new variable named goose image. Const goose image. Set its value equal to a JSX image element. Give the image an attribute with the name of source. So put this on a new line, indent that. Give it an attribute source equals. Set the attribute's value equal to the variable goose. So up here, goose is a link to this image of a goose. So I'm gonna its source is equal to goose, and I think that's it. Use root.render to render the goose image. So root.render, and we're gonna render goose image. Look at that beautiful goose. Event listeners in JSX. JSX elements can have event listeners, just like HTML elements can. Programming in React means constantly working with event listeners. You create an event listener by giving a JSX element a special attribute. Here's an example. So image on click equals click alert. An event listener attribute's name should be something like on click or on mouse over. The word on plus the type of event that you're listening for. Look through the common components list in React docs to browse supported event names. I will do this just to give myself an idea. So common components, e.g. div, all built-in browser components such as div support some common props and events. So it's a lot. Special React props are supported for all buildings. So children, okay, this is overwhelmingly a lot, but you see here, like, on click, a mouse event handler function fires when the primary button was clicked on the pointing device. So on copy, on cut, there's a bunch of stuff. Okay, so an event listener attributes name. Okay, wait, I already read that. To browse supported event names, an event listener attribute's value should be a function. The above example would only work if click alert were a valid function that had been defined elsewhere. So we have this function click alert, you clicked this image on click alert. So again, an event listener attribute's value should be a function. So this is the event listener attribute. This is its value. Its value is click alert, and click alert should be a function. The above example would only work. So this above example right here would only work if click alert were a valid function that had been defined elsewhere. So on click, we're gonna run this function click alert, and this function says we're getting an alert. You clicked this image. Note that in HTML, event listener names are written in all lowercase, such as on click or on mouse over. In JSX, event listener names are written in camel case, such as on click or on mouse over. Take a look at line 19. Root.render is being passed a null argument. Render kitty by replacing the null with kitty. So we're going to replace this null with kitty. We're going to get a kitty. Oh, look at the kitty. Oh, look at the kitty. Add on click attribute to the image element. So we have this image element. We're going to add an on click. Set on click's value equal to make doggy function. We have this make doggy function up here. Call this extremely useful function on an image. The image will become a picture of a doggy. So it sets its source to this image of a dog and the alt of doggy. So on click, we can do make doggy function. Remember, since attributes are part of JSX expressions, you will need to inject JavaScript in order to use make doggy. Click run, and then click on the browser image to change the kitty into a doggy. So I think this should work. Okay, so now when we click it, it becomes a doggy. But see, it's static. We can't click it once and have it change back. It's just on that one click, it becomes a doggy, and that's it. JSX conditionals, if statements that don't work. Great work. You've learned how to use curly braces to inject JavaScript into a JSX function. Here's a rule that you need to know. You cannot inject an if statement into a JSX expression. This code will break. So if we do h1 with if purchase.complete, thank you for purchasing an order, inside the h1. What if you want a JSX expression to render, but only under certain circumstances? You can't inject an if statement. What can you do? You have lots of options. In the next few lessons, we'll explore some simple ways to write conditionals, expressions that are only executed under certain conditions in JSX. JSX conditionals, if statements that do work. How can you write a conditional if you can't inject an if statement into JSX? One option is to write an if statement and not inject it into JSX. Look at if.js. Follow the if statement all the way down, all the way from line 8 down to line 20. So we have this: if the user.age is greater than or equal to drinking age, the message is a header, hey, check out this alcoholic beverage. Else, the message will be, hey, check out these earrings I got at Claire's. Great. And then we render the message depending on the user's age. Where are we getting the age from? Whatever. If.js works because the words if and else are not injected between JSX tags. The if statement is on the outside, and no JavaScript injection is necessary. This is a common way to express conditionals in JSX. So it gets the message gets decided in this if-else statement, and then that message itself gets directly sent to render rather than sending the whole conditional to render. Open app.js. Starting on line 18, write an if-else statement using if.js as a guide. So if coin toss is equal to heads, so if coin toss is equal to heads, then we're going to do execute image equal, okay, yeah, set it to image. So if that, then image, which we have defined image image equals image source equals pics.kitty. Inside of the else clause, so else execute image equals image source equals pics.doggy. I'm a little confused where the semicolon goes properly here, but regardless, I believe these need semicolons. So, in other words, if the coin lands heads, then you should get a picture of a kitty. And if the coin lands tails, then you should get a picture of a doggy. So, we have this function coin toss. This function will randomly return either heads or tails. Return math.random less than 5 if it is, then tails. If it is, then heads. If not, then tails. We have these declared pictures. It's a structure, so pics has a kitty and then a link, and a doggy and a link, and then we declare this image variable. So if the coin toss, so we run this function, and if it equates to heads, then we get then the image gets assigned this JSX, which is this image with the source of pics kitty. Otherwise, the image gets assigned this image source pics doggy. So run this. The else clause should set the previously declared image variable equal to image source equals pics. Awesome. At the bottom of the file, call root.render. For root.render's argument, pass in image. Click run, refresh the browser several times. Does the picture change? It's cool. For some reason that dog one is coming up a lot more. Here we go. It's evening out a little bit, kind of. Still a lot of dogs. Okay. JSX conditionals, the ternary operator. There's a more compact way to write conditionals in JSX, the ternary operator. The ternary operator works the same way in React as it does in regular JavaScript. However, it shows up in React surprisingly often. Recall how it works. You write x, y, z, where x, y, and z are all JavaScript expressions. When your code is executed, x is evaluated as either truthy or falsy. If x is truthy, then the entire ternary operator returns y. If x is falsy, then the entire ternary operator returns z. Here's how you might use the ternary operator in a JSX expression. So we have const headline equals h1, age greater than or equal to drinking age. If so, buy drink. If not, do teen stuff. In the above example, if age is greater than or equal to drinking age, then headline will equal h1 buy drink. Otherwise, headline will equal h1 do teen stuff. Take a look at app.js. On line 16, replace x, y, and z so that the expression returns kitty if coin toss is heads up and doggy if coin toss is tails. So we have this const image equals image source. So first we're going to check if coin toss. So coin toss equal to heads. What am I doing? Why'd I put it there? So this image will pull the source from here. Okay, so I see. Right, so we're gonna do, it's kind of a lot to try to fit on one line, but coin toss equal to heads. If so, then return dot kitty, else return dot doggy. Believe this should work. So coin toss equals heads. I added the dot unnecessarily, but I'm surprised because where does the dot come in then? Because shouldn't it be pix.kitty? Pix.doggy. Huh. So I guess maybe the fact that it's in brackets will let it know that the outcome just automatically will receive a dot before it. Interesting. So JSX conditionals, ampersand, so and. We're going to cover one final way of writing conditionals in React, the and operator. Like the ternary operator, and is not React specific, but it shows up in React very often. In the last two exercises, you wrote statements that would sometimes render a kitty and other times render a doggy, and would not have been the best choice for that code. And works best for conditionals that will sometimes do an action, but other times do nothing at all. Here's an example: const tasty, on order list item applesauce, so not baby, and list item pizza, age greater than 15, and list item Brussels sprouts, age greater than 20, and list item oysters, age greater than 25, and list item grappa. In the expression on the left of the, if the expression on the left of the ampersand evaluates as true, then the JSX on the right of the ampersand will be rendered. If the first expression is false, however, then the JSX to the right of the ampersand will be ignored and not rendered. So okay, we're going to cover one final way of writing conditionals in React, the and operator. Like the ternary operator, and is not React specific, but it shows up in React very often. In the last two exercises, you wrote statements that would sometimes render a kitty and other times render a doggy, and would not have been the best choice for that code, and works best for conditionals that will sometimes do an action, but other times do nothing at all. So here's an example. So we have this unordered list for tasty. It's an unordered list, and this first list item will always be applesauce. And then in the case that baby is falsy, then we will have a list item of pizza. In the case that the age is less than 15, we'll give them Brussels sprouts. In the case that the age is less than 20, they'll also get oysters. In the case that the age is, I'm saying less than, I mean greater than. But greater than 25, then they get grappa. If the expression on the left of the and evaluates as true, then the JSX on the right of the ampersand will be rendered. If the first expression is false, however, then the JSX to the right of the ampersand will be ignored and not rendered. You've been building a React website all about your favorite foods. You're excited to share your website with your friends, and yet at the same time you fear the cruel, icy harshness of their judgment. On line 15, use the and operator to make it so that this expression, list item nacho cheese straight out the jar, and list item, will only appear if not judgmental. Feel free to use the example code as a guide. When you click run, every time you refresh the browser, there will be a 50% chance that judgmental will be true. Refresh until you see both versions of your list. So here we have my favorite foods: sushi burrito, rhubarb pie, nacho cheese straight out the jar, broiled grapefruit. So we're importing React, create root, const container, document element, document get element by the app, const root, create root container. Judgmental will be true half the time, so we have this const judgmental. It's math random, less than 0.5. Const favorite foods equals, so div my favorite foods, unordered list sushi burrito, list item rhubarb pie, list item nacho cheese straight out the jar, broiled grapefruit, unordered list render favorite foods. So excited to share online, use the and operator to make it so that this expression will only appear. Okay, so list item. Okay, so wrap all of it in curly braces. And add the ampersands. So this will only happen if the expression before it is truthy. And what we need is not judgmental. Hitting the wrong buttons. Sorry. Not judgmental. Don't need this semicolon. This should evaluate properly. Okay. See if we keep reloading the page. Oh yeah, so we get it sometimes. Cool. Dot map in JSX. The dot map array method comes up often in React. It's good to get in the habit of using it alongside JSX. If you want to create a list of JSX elements, then using dot map is often the most efficient way. It can look odd at first, so const strings equals home shop about me, const list items equals strings dot map, string points, or I want to say points to. I don't really know how to pronounce this. I gotta look. In this line of React code, I don't know, is this JavaScript or is this React? I guess this line itself is JSX, or I'll just say JavaScript. So in this line of code, how is the meant to be pronounced? Arrow or fat arrow. So string arrow. So the line const list items equals strings dot map string arrow list item string list item. Okay. So the dot map array method comes up often in React. It's good to get in the habit of using it alongside JSX. If you want to create a list of JSX elements, then using dot map is often the most efficient way. It can look odd at first. So we have this strings list of home, shop, and about me. Then we have this list items, strings dot map, string arrow, list item, string, list item. Unordered list, curly braces, list items, unordered list, close. In the above example, we start out with an array of strings. We call dot map on this array of strings, and the dot map call returns a new array of list items. So strings, so we're mapping. So we're taking string. So I think it's like for string and strings kind of. So strings.map, each string, arrow, list item with the string. And this becomes list items. So list items becomes a mapping of each of these to a list item. And then we can do unordered list with list items, and we'll naturally have 3 list items converted from here. So again, in the above example, we start out with an array of strings. We call .map on this array of strings, and the .map call returns a new array of list items. On the last line of the example, note that list items will evaluate to an array. List items will evaluate to an array because it's the returned value of .map. JSX list items don't have to be in an array like this, but they can be. So this is fine in JSX, not in an explicit array. So unordered list, list item item 1, list item item 2, list item 3, and unordered list. This is also fine. If we do const list item array equals list item 1, list item 2, list item 3. And then either way we can do unordered list of list item array. So this is one way to render things in JSX. This is another way to render things in JSX. So in this we have the unordered list, and inside of it are some list items just explicitly coded into our JSX object. But we can also create this object list item array and populate it with an array of these 3 list items. And when we wrap it in these curly braces and inject that into an unordered list, it will automatically print out the array as though it were this. It's cool. You can see that .map call is partially set up. A .map call is partially set up. So we have this const people list equals people.map person I. So people. So for each person in here, what does the I mean? I don't know. This expression should consist of a list item element containing the person variable. Feel free to use the first example as a guide. So on line 10, write an expression to complete the .map call. This expression consists of a list item containing the person variable. So const people list will be list item person. Do we need their index also? Person variable, no. It's just person. Okay, and then root render. On line 14, call root render, root.render. For root render's argument, write a UL element. In between UL tags, use curly braces to inject the people list. Add this semicolon at the end, and then it should render a list item for each person. Yep. Keys. When you make a list in JSX, sometimes your list will need to include something called keys. So we have unordered list item key li01, example 1, list item key li02, example 2, list item key li03, example 3. Again, when you make a list in JSX, sometimes your list will need to include something called keys. A key is a JSX attribute. The attribute's name is key. The attribute's value should be something unique, similar to an ID attribute. Keys don't do anything visible. React uses them internally to keep track of lists. If you don't use keys when you're supposed to, React might accidentally scramble your list items into the wrong order. Not all lists need to have keys. A list needs keys if either of the following is true. 1. The list items have memory from one render to the next. For instance, when a to-do list renders, each item must remember whether it was checked off. The items shouldn't get amnesia when they render. A list's order might be shuffled. For instance, a list of search results might be shuffled from one render to the next. If neither of these conditions is true, then you don't have to worry about keys. If you aren't sure, then it never hurts to use them. So again, not all lists needs to have keys. A list needs keys if either of the following is true. 1. The list items have memory from one render to the next. In this case, they will need a key if they are meant to have memory from one render to the next. For instance, When a to-do list renders, each item must remember whether it was checked off. The items shouldn't get amnesia when they render. 2. A list's order might be shuffled. For instance, a list of search results might be shuffled from one render to the next. If neither of these conditions is true, then you don't have to worry about keys. If you aren't sure, then it never hurts to use them. On line 10, give the list item element a key attribute. So we have line 10, give it key. What do you want me to put the key? What should the key's value be? Each key must be a unique string that React can use to correctly pair each rendered element with its corresponding item in the array. So for each element in people, we must generate a unique value. How can you get .map to produce unique keys? First, add an I parameter to .map's inner function so that you can access each person's unique index. So people.map person I. It's already there. Now you can get a unique key on each loop by adding the following attribute to the list item. So we have key equals person plus I. It's pretty cool, pretty cool. Wait, did it work? Pretty cool. React.create element. You can write React code without using JSX at all. The majority of React programmers do use JSX, but you should understand that it is possible to write React code without it. The following JSX expression, const h1 equals h1 hello world, close h1, can be rewritten without JSX like const h1 equals react.create element. h1 is the type of element, null, I don't know what that means yet, and then the value it's going to hold is going to be hello world. When a JSX element is compiled, the compiler transforms the JSX element into the method that you see above. React.create element. Every JSX element is secretly a call to React.create element. We won't go in depth into how React.create element works, but check out the React documentation on create element to learn more. Take a look at the following JSX element. Const greatest div ever equals div I am a div. In app.js, create the above element without using JSX. So we do create React.create element. It's going to be div. Don't know what this null is for, but we'll put it there. And then I am a div. I am a div. I am div. Oh, my fault. Cool. Review. Congratulations, you have learned a wide variety of JSX concepts. If you don't feel like you've mastered them all yet, that's okay. These concepts will come up again and again throughout your React learning journey. You are now ready to put your JSX knowledge to use. Try modifying the app.js file and experimenting with JSX elements. When you're ready, press up next to move on to the next lesson. So if we have this container, document, element ID, app, const root is create root container. Have this const people, row, provost, gear, const people list equals people.map. We're mapping the person and the index. We just have this list item key, person, list item. What we could do maybe is make this an ordered list. Let's experiment with that. See how that renders. Broke everything. It's not rendering at all. Why isn't it rendering? Nothing's rendering. Okay. I don't know. What did I do? Okay. This is weird. Whatever. I guess I'm going on. Upgrade to get more from Code Academy. Skip that for now. What I really need to learn is just like actions. Yeah. So, time is it? Doing pretty good. React components. React applications are made of components. What's a component? A component is a small, reusable chunk of code that is responsible for one job. That job is often to render some HTML and re-render it when some data changes. Again, a component is a small, reusable chunk of code that is responsible for one job. That job is often to render some HTML and re-render it when some data changes. Take a look at the code below. This code will create and render a new React component. So we import React from React, import React document object model from React document object model / client. We create a function called myComponent, which returns a header hello world, and then we have React dom.createRoot with a document.getElementById app, and this is rendering myComponent. A lot of these look unfamiliar, but do not worry. We're going to unpack that code one small piece at a time. By the end of this lesson, you'll understand how to build a React component. Take a look at app.js and index.js. Explore the contents of the files and press run. So app.js, import React from React, function app, return h1 hello again world, and then export default app. So index.js has React from React, React DOM. It's importing this, which is exporting this. So pretty much just exports hello again world. And then we're importing that. And we have React DOM, create root, document, get element by ID, and then we're rendering app. So it renders app, and app is just this, and it'll render hello again world as a header. Import React. The first React component we created in the last exercise started with importing React. The line that did this is import React from React. This creates an object named React, which contains methods necessary to use the React library. React is imported from the React package, which should be installed in your project as a dependency. With the object, we can start utilizing features of the React library. By importing the library, we can use important features such as hooks, which we'll explain in detail later. For the next few exercises, we'll be working in two files, app.js and index.js. In a React application, the app.js file typically is the top level of your application, and index.js is the entry point. In line 1 of app.js, use import to import the React library. Save the library in a variable named React. So import React from React. Nice. Index.js also needs React. In line 1 of index.js, use import to import the React library. Save the library in a variable named React. And run this, and then next. Import React DOM. Another import we need in addition to React is React Document Object Manager. Import React DOM from React DOM client. The methods imported from React DOM interact with the Document Object Manager, Document Object Model. The methods imported from React do not deal with the Document Object Model at all. They don't engage directly with anything that isn't part of React. To clarify, the Document Object Model is used in React applications, but isn't part of React. After all, the Document Object Model is also used in countless non-React applications. Methods imported from React are only for pure React purposes, such as creating components or writing JSX elements. Although we imported React in both app.js and index.js in the previous exercise, we will only import React Document Object Model in index.js. React Document Object Model deals with Document Object Model specific methods that should be used in index.js, which is the entry point of our application. In index.js, import the React Document Object Model library on line 2, store the result in a variable named React DOM. So import React DOM from React DOM client. Create a function component. Okay, so you've learned that a React component is a small, reusable chunk of code that is responsible for one job, which often involves rendering HTML and re-rendering it whenever some data changes. It's useful to think of components as smaller pieces of our interface. Again, you've learned that a React component is a small, reusable chunk of code that is responsible for one job, which often involves rendering HTML and re-rendering it whenever some data changes. It's useful to think of components as smaller pieces of our interface. Combined, They are the building blocks that make up a React application. In a website, we can create a component for our search bar, another component for our navigation bar, and another component for the dashboard content itself. Here's another fact about components. We can use JavaScript functions to define a new React component. This is called a function component. In the past, React components were defined using JavaScript classes, but since the introduction of hooks, something we'll discuss later, function components have become the standard in modern React applications. Again, here's another fact about components. We can use JavaScript functions to define a new React component. This is called a function component. In the past, React components were defined using JavaScript classes, but since the introduction of hooks, something we'll discuss later, function components have become the standard in modern React applications. After we define our functional component, we can use it to create as many instances of that component as we want. Let's take a look at the example from the first exercise. So we import React from React. We have this function myComponent, return h1 hello. I'm a functional React component. Export default myComponent. On the third line, a function is defined with the name myComponent. This is the third line. Inside the function returns a React element in JSX syntax. Return h1 hello. I'm a functional React component. Combined, this makes a basic React functional component. On the last line of the above code block, myComponent is exported so it can be used later. A lot of it is still unfamiliar, but you can understand more than you could before. Let's keep going. In line 4 of app.js, declare a new function component. You can call this whatever you'd like. Don't put anything between the curly braces just yet. So we have this function. I'll call it new component. Name a functional component. Good. Creating a JavaScript function is the way to declare a new functional component. When you declare a new functional component, you need to give that component a name. On our finished component, our component's name was myComponent. Function myComponent, return h1 hello world. Function component names must start with capitalization and are conveniently created with Pascal case. Due to how JSX tags are compiled, capitalization indicates that it is a React component rather than an HTML tag. This is a React specific nuance. If you are creating a component, be sure to name it starting with a capital letter so it interprets it as a React component. If it begins with a lowercase letter, React will begin looking for a built-in component such as div and input instead and fail. Edit the code so that the functional component is named myComponent with a capitalized first letter and follows the Pascal case naming convention. So myComponent. Function component instructions. Let's review what you've learned so far. Find each of these points in app.js and index.js. On line 1 of app.js and index.js, import React from React creates a JavaScript object. This object contains properties that are needed to make React work, such as react.createElement. On line 2 of index.js, import React DOM from React DOM client creates another JavaScript object. This object contains methods that help React interact with the DOM, such as React DOM.createRoot. On line 3 of app.js, by writing a JavaScript function, a function component was defined. We can't see this component quite yet, as it's more of a factory that produces instances of itself when used. If we want to see it, we need to render it into the DOM. Whenever you create a function component, you need to give that function component a name. This name should be written in Pascal case, like this, upper camel case. Something that we haven't talked about yet is the body of your function component, the pair of curly braces after the function definition, and all of the code between those curly braces. Like all JavaScript functions, this one needs a body. The body will act as a set of instructions explaining to your function component how it should build a React component. Here's what your function component would look like on its own, without the rest of the function declaration syntax. Find it in app.js. Return h1 hello. This is a function component body. That doesn't look like a set of instructions explaining how to build a React component, yet that's exactly what it is. Click Next. and we'll go into how these instructions work. The return keyword in function components. When we define a functional component, we essentially define a factory that can build the appropriate combination of elements every time we reference its name. It builds it by consulting a set of instructions that you must provide. If you're thinking, that sounds just like what a regular JavaScript function is for, then you're right. Functional components can be thought of in a very similar vein to regular JavaScript functions, except that their job is to assemble a portion of the interface based on instructions given. Let's talk a bit more about these instructions. For starters, these instructions should take the form of a function declaration body. That means that they will be delimited by curly braces, like this: function button, curly braces. Instructions go here between the curly braces. Our instructions can include a combination of markup, CSS, and JavaScript to produce the desired result. The one thing we must always include is a return statement. So again, our instructions can include a combination of markup, CSS, and JavaScript to produce the desired result. The one thing we must always include is a return statement. The function is expected to produce JSX code that can be used to render something onto the browser screen. Thus, when we define functional components, we must return a JSX element. So function back button would return this button with back to home. Of course, this doesn't quite make button back to home button render onto the browser screen yet. We've only defined our component. Let's keep going so we can see how to render it and why the return statement was necessary. Time to complete the component we've been working on. In the body of your component definition, write return. Now, let's fill out that line. Have the return statement return the JSX expression, h1 hello world. I need the oh, you know what? I think it's, oh yeah, cool. It's not capitalized, but whatever. I'll just do that. So, importing and exporting React components. There's a little bit more work we have to do before we can use our defined component and have it rendered onto the DOM. We previously mentioned that a React application typically has two core files, app.js and index.js. App.js file is the top level of your application, and index.js is the entry point. So far, we've defined the component inside of app.js, but because index.js is the entry point, we have to export it to index.js to render. Components in React are great because they are reusable. We can keep our component pieces separated, organized, and reusable by putting them into separate files and exporting them to where we need them. Again, components in React are great because they are reusable. We can keep our component pieces separated, organized, and reusable by putting them into separate files and exporting them to where we need them. To export them, we can prefix it with the export declaration and specify if it is a default or named export. In this case, we'll stick with default. If you need a refresher on export, peruse the MDN web docs. After the function component definition in app.js, we can default export our component like so. Export default my component. We can head into our index.js file to import our component from /app. So import, so index.js, do import my component from .app. So we have this, and they're in the same folder, so we can just say .app, and we're importing my component, which is being exported. So allow us to use my component in index.js. In app.js, export your function component, done. Export default. In index.js, import your function component at the top with the variable name my component. Run the code. You'll see that still nothing will appear on the browser. That's because importing and exporting are not enough yet. We need to learn how to use the components and render them. Let's go. Using and rendering a component. Now that we have a defined function component, we can start using it. We can use it with an HTML-like syntax that resembles a self-closing tag, myComponent / end it. If you need to nest other components in between, you may also use an opening and corresponding closing tag structure. So you could do myComponent with an element in there and closing myComponent. However, to render our component to the browser, we must rely on the createRoot and .render methods from the React DOM library. This should be done in our entry point in Next.js. First, we call the createRoot method to create a React root container for displaying content. React applications typically have a single root DOM node, and everything inside it is managed by React DOM. In other words, we give createRoot a DOM element to render in, and React will take over managing the DOM inside it. Here's an example: React DOM.createRoot document.getElementById app. Great, let's break it down a bit further. Document.getElementById app returns a DOM element from index.html. So here we see index.html, HTML language English, head, meta, char.set.utf, meta, viewport, content with device, link, relative style sheet from style CSS, body, the ID is app, okay, and script is using this course bundle.min script, script source index compiled. So when it is calling app, it's really based on this ID here, and it's calling this body. And this is happening in app.js, or no, this is happening in, where is this happening? I don't know. But okay, so again though, React DOM.createRoot document getElementById app. So this returns a document object model element from index.html. .createRoot receives the document object element as the first argument and creates a root for it. CreateRoot returns a reference to the root container on which you can call methods like .render. After the root is created, all that's left to do is call the .render method on the returned root and display the React component like so: React DOM.createRoot document.getElementById app.render myComponent. From here, React will display myComponent in the root and make it appear on the screen. In an application fully built with React, you will only need to do this once. Once this is set up, React will manage the document object model of your application, and any updates to the user interface is taken care of efficiently. Adding more components should take place in your top-level app.js file. Instructions: it's time to practice rendering your own component. To start, tell React where to render components by specifying a document object element as the root element for your app. Open up index.js and begin by calling .createRoot to create a React root to display your content in the main element with the ID of app. So, in the main element means inside here is where our app is going to live. It's where our user interface is really going to live. So, we imported React DOM, so now we're going to use it. React. Oh, this is index. So, oh wait, no, yeah, I'm supposed to be an index. That's the entry point. So, we use React DOM. Dot. So using the React document object model, what we're going to do is we're going to create a root. This is going to be the entry point into our interface. Now inside this root, create a React root to display your content in the main element, the ID. So inside this root, we're going to put a document. We're going to get which document it's going to be by using the getElementById. And this is, I believe, a React method. And so we're going to call app, which is calling this based on its ID. And so this is where everything that we build is going to live now. And now we're going to use .render on it to insert our myComponent into it. So that's all one word, myComponent, closing. And now, so that's causing, what this is doing is it's causing this function to run and return hello world. And it's going to pull that and render it into here. So essentially what it's doing is taking this and putting it in here like that, but we're just doing it dynamically with code. Run it. Now that you have the root, it's time to call .render on it and display the React component. In index.js, use .render and pass in the myComponent component. Click run to test out your code. The world waves hello back. Hello world. So now on to the next review. In this lesson, you've learned about a foundational React concept, components. Before you go, here's a recap. React applications are made up of components. Components are responsible for rendering pieces of the user interface. To create components and render them, React and React DOM must be imported. React components can be defined with JavaScript functions to make function components. Function component names must start with a capitalized letter, and Pascal cases the adopted naming convention. Function components must return some React elements in JSX syntax. React components can be exported and imported from file to file. A React component can be used by calling the component name in HTML like self-closing tag syntax. Rendering a React component requires using .createRoot to specify a root container and calling the render method on it. That was a lot, but components are at the core of React, and they're one of the reasons why React is such a powerful tool. If you'd like to practice your learned skills, consider these challenges. Create a new JavaScript file in the file directory. Sure, let's do it. New file, new folder. Define a new function component and export it. So call it main.js. Well, actually, no, let's call it, I don't know, paragraph. Paragraph.js. Inside it, define a new function component and export it. So in our app.js, the way we defined a new function component was by first we import React. So defining paragraph function component. So first we import React. Import React from React. Don't think we need a closing. Oh, we do need a semicolon. So first we import React, then we define a function. So function my paragraph, return p. This is a paragraph. This is a paragraph. And we don't need a semicolon. Oh, we do. And then export it. Export default my paragraph. Cool. And then to render it, we go in index.js and we can render. So that's the thing, is how do you render multiple things? To me, it seems redundant to just test this out, see how it works. It's not rendering now though, and I don't know if it's because of me. Let's see what happens if I do this. Huh. Well, let's ask Copilot. What's the proper way to render multiple components in React? Right now, this syntax isn't loading either, isn't rendering. React, if you want to render multiple components, let it load a little bit. In React, if you want to render multiple components, they need to be wrapped in a single parent component. This is because the render function can only return one parent element. You can use a React fragment or a div to wrap your components. Here's how you can do it. So it makes sense. Should have remembered that from earlier. Okay, so this then. I don't even think we need this. And indent these. Now let's see if it works. Still didn't work. What's the discrepancy? Import. Did we import it? I don't even think I imported it. Silly. Import my paragraph from dot paragraph. Now let's see if it works. Sweet. Let's see what Copilot had to say. So yeah, that's what we got in there. In the above code are shorthand for React fragment. This allows you to group a list of children without extra nodes to the DOM. If you prefer, you can also use a div. Remember to import my paragraph. Yep. Okay. What's next? Multi-line JSX in a component. All right, cool. Let me see what time. I'm doing pretty good. Have another hour and a half. How much is left in the syllabus? So React components, we're about halfway through. And then we have this components interacting. So quick break. Be right back. 1 2 1 2. There's a little bit of sound coming in. I don't like that. Huh. Okay. Sorry for the long break. I had to wash my face and heat up the last of my coffee and put the sweater on. So I'm starting to get tired. Microphone check 1 2. Check 1 2. Check 1 2. Check 1 2. Okay. Okay. Let's get into it. So, use multi-line JSX in a component. In this lesson, you will learn some common ways that JSX and React components work together. You'll get more comfortable with both JSX and React components while picking up some new tricks. Take a look at this HTML block quote P. First of all, I'm sorry, I'm just constantly feeling like, especially right now, I feel like there's something I'm forgetting. I just gotta check my calendar. No, I'm good. Okay, sorry. Again, use multi-line JSX in a component. In this lesson, you will learn some common ways that JSX and React components work together. You'll get more comfortable with both JSX and React components while picking up some new tricks. Take a look at this HTML block quote P. The world is full of objects more or less interesting. I do not wish to add any more. NP, site, anchor, target, blank, href, Wikipedia to Douglas Hubler, and the words Douglas Hubler, and blank means it'll open in a new tab, and site, and block quote. How might you make a React component return this HTML? Select quotemaker.js to see one way of doing it. So if we go to quotemaker, importing React, we have this function quotemaker, which returns this block quote. The key thing to notice in quotemaker is the parentheses of the return statement on lines 4 and 16. Until now, your function component return statements have looked like this without any parentheses on a single line. However, a multi-line JSX expression should always be wrapped in parentheses. That's why quotemaker's return statement has parentheses around it. Here's another quote formatted in the same way. Block quote P. What is important now is to recover our senses. Site blank Susan Sontag. Block quote. In myquote.js, write a React component that returns this HTML. So we have myquote. So first of all, import React. Import React from React, and then declare function. So function my quote, and we're gonna return multi-line. Copy this. Indentation got screwed up. Is that right? No, that's right. And now we're gonna export it. How does the how do we wrap this? I'm just questioning if these need semicolons, but I don't think they do. Oh wait, I could go to quotemaker. Oh, they do. Yeah, semicolon there, semicolon there. Okay. So in my quote create a React component returns this HTML. Use quotemaker as a guide. Remember to import React at the top of the file, and remember to export your component at the bottom. If you don't like this quote, feel free to use a different one. So import, make the function, put the return in it. Yep, all looks good. Use a variable attribute in a component. Take a look at this JavaScript object named redPanda. Const redPanda equals source with the link to it, the alt text, and its width. How could you render a React component with an image of redPanda and its properties? Select redpanda.js to see one way to do this. Note all the curly brace JavaScript injections inside the return statement. So all the curly braces. So we have this function red panda, which returns a div with a header of cute red panda, and then an image with the source is pulled from red panda's source up here. The alt is pulled from red panda's alt, and the width is pulled from red panda's width, and the div, and then we're going to return that, or export it, I should say. Note all the curly brace JavaScript injections inside the return statement. You can and often will inject JavaScript into JSX inside the return statement. Select owl.js. Start by importing React from the React library. Let's create our component. In owl.js, declare a new function component named owl. So function owl should return an empty div. Feel free to use redpanda.js for guidance. Although you're not done with the component, export it so that you can see your progress being rendered in the browser window as you work. At the bottom of the owl.js file, default export your owl component. Our owl object has two properties, title and source, which has a link to an image. We'll display both of these starting with the title. Nest an h1 element inside of your div element. So put the parentheses there, put this on the next line, add the closing parentheses, add some semicolons. I don't think this is going to need the semicolon now. Put that down there, and then nest in h1. Nest in h1, use the value of owl.title as the content of the h1 element. Remember, you will also have to use curly braces to access owl.title since it's a JavaScript property. Don't forget to wrap the whole multi-line JavaScript expression in parentheses. So just do owl.title. Will it render? Excellent, owl. Still inside the div tags, make a new line after the h1 tags. On your new line, add an image element. And your image element should have two attributes, a source of owl.source and an alt of owl.title. So a source equals owl.source and a title equals owl.title. Shall it work? Yes, it shall. What happened? Did you add an alt attribute? Oh yeah, my fault. And an alt of owl.title, got you. Okay. Next up, putting logic in a function component. A function component must have a return statement. However, that isn't all that it can have. You can also put simple calculations that need to happen before returning your JSX element within the function component. Here's an example of some calculations that can be done inside a function component. Here we have function random number first, some logic that must happen before returning. Const n equals math.floor, math.random times 10 plus 1. So that's calling math.random to return a random number between 0 and 1, multiplying it by 10. So we get a random number between 0 and 10. We add a 1 to it. So I guess it becomes a random number between 1 and 11. And then math.floor, we're making sure it's an integer. I'm returning that integer to this header. Watch out for this common mistake. So a lot of people will put all the logic in the return statement. That's not what you do. In the above example, the line with the const n declaration will cause a syntax error as it should come before the return. Let's make a function component with some logic in it. Start by importing React from the React library at the top of the friend.js file. So import React from React. Create a new function component named friend. So function friend. Your function component should just return an empty div for now. Although you're not done with the component, export it so that you can see your progress being rendered in the browser window. Export default friend. Time to add some logic. Before the return statement, declare a new variable named friend. Set friend equal to either friends 0. Okay. Wait, I could choose between a monkey weirdo, an earnest frog, or an alpaca. I think I'm gonna go with the alpaca. So, time to add some logic. Before the return statement, declare a new variable named friend. Set friend equal to either friends 1, friends 2, depending on which friend sounds most appealing to you. Definitely the alpaca. It's between the alpaca and the monkey. Inside the div element in the return statement, right here, add an h1 element. So, make it multi-line. Add an h1. Inside of the h1 tags, inject friend.title. Finally, let's meet your new friend by adding a picture of them. Still inside of the div tags, make a new line after the h1 tags. On the new line, add an image element. Give the image tag an attribute of source with the value of friend. Friend.source. What are we gonna see? Damn, why I gotta call him yikes? Look at that beautiful hair. This is a beautiful alpaca. Could use some dental work, but hey, couldn't we all? Let's keep going. Use a conditional in a function component. How might you use a conditional statement inside of a function component? Select today's plan.js to see one way of doing it. Notice that if the if statement is located inside of the function component but before the return statement. Notice that the if statement is located inside the function component. Okay, so again, how much you use a conditional statement inside of a function component? Select today's plan.js to see one way of doing it. So we're at today's plan, we're importing React, have this function today's plan, declaring a variable named task, declaring a variable named apocalypse and initializing it to false. If it's not the apocalypse, then the task is to learn React.js. Otherwise, task is to run around if it is the apocalypse. And we're going to return h1 today. I'm going to do something depending on whether it's the apocalypse, and we're going to export default today's plan. So select tonight's plan. You'll see a variable named 50/50. It's math random. Less than 0.5. 50/50 will equal true half the time and false half the time. Begin by writing the skeleton of a new function component named tonight's plan. So function tonight's plan. Oops. From tonight's plan. Okay, created the skeleton. At the bottom of tonight's plan.js, default export. Create your first condition. If 50/50 is true, then tonight's plan should return this element. So if 50/50, h1 so I guess we'll say message, what do they call it over here? Called it task. So tonight I'm going out, woo, I'll call it plan. Plan equals tonight I'm going out, woo. Else plan equals I don't understand how they want me to, like, at what point should I try to run it? I did. Oh, okay. Oh, I see. Because it doesn't return anything. So I guess, I don't know. We'll do return. Oh, I see. So if 50/50, put the return statement in the if. Return. Tonight I'm going out. Woo. And create your second condition. So else return. Tonight I'm going to bed. Woo. Run your code and determine what tonight's plan is. Looks like right now tonight I'm going to bed, which is my preferred plan, honestly. Oh yes, still the preferred plan. Okay, let's go. Event listener and event handlers in a component. Your function components can include event handlers. With event handlers, we can run some code in response to interactions with the interface, such as clicking. Again, event listener and event handlers in a component. Your function components can include event handlers. With event handlers, we can run some code in response to interactions with the interface, such as clicking. So function my component, function handle hover, alert, stop it, stop hovering, return div, on hover, handle hover, close div. Cool, it's reactive. That's why they call it that. In the above example, the event handler is handle hover. It is passed as a prop to the JSX element div. We'll discuss more on props in a later lesson, but for now, understand that props are information passed to a JSX tag. The logic for what should happen when the div is hovered on is contained inside the handle hover function. The function is then passed to the div element. Event handler functions are defined inside the function component and, by convention, start with the word handle, followed by the type of event it is handling. There's a small quirk you should watch out for. Take a look at this line again. Return div on hover handle hover. The handle hover function is passed without the parentheses we would typically see when calling a function. This is because passing it as handle hover indicates it should only be called once the event has happened. Passing it as handle hover will trigger the function immediately, so be careful. In button.js, find the button tags inside of the return statement. So here we have the tags. Give this button element an onClick attribute. So do onClick. The attribute's value should be the handle click function. So its value, so don't need these, just handle click. And this handle click function is giving an alert for a submission successful. So when we click this button after we run this, so right now if I click it, nothing's happening, right? So now what we've done is we've created a onClick attribute, which when it's clicked, we'll get an alert saying the submission was successful. So let's run it, see what happens. Okay, so now submission successful. Look at that, awesome. Review. Congratulations, you have finished the lesson on React components. Here's a short recap of the concepts introduced in this lesson. Function components can return multiple JSX lines by nesting the elements in a parent element. Variable attributes can be used inside of a React component with JavaScript injections. React components support logic by putting the logic statements above the return statements. Components can conditionally return, let it sink in, restart. Function components can return multiple JSX lines by nesting the elements in a parent element. Variable attributes can be used inside of a React component with JavaScript injections. React components support logic by putting the logic statements above the return statements. Components can conditionally return JSX elements by putting conditional statements inside of the components. Components can respond to events by defining event handlers and passing them to the JSX elements. Great job on tackling these complex topics. You have spent a lot of time studying React components in isolation. Now it's time to learn how components fit into the world around them. Instructions: if you would like to practice your learned skills, consider these challenges. Add logic to the myQuote component to produce different quotes based on different conditions. Add elements onto the screen that can respond to events, such as clicking or hovering. Make sure to define event handlers for them within the component. Let's try it out. So add logic to the myQuote component to produce different quotes based on different conditions. So let's say let's do an if statement. So if we'll just do okay, so if math.random is less than 0.5, and we can return this quote in that case. Actually, I kind of want to test something else out. We'll do what is important now is to recover our senses. Okay, so we'll do is important equals recover our senses. We're going to make this a variable. It's important. And we'll do else. So if this doesn't evaluate true, so if math.random ends up being greater than 5, what's going to happen is important will be equal to get money. So now this will execute if this, then that, else that, and then what we're going to do is make sure this is I hate it when it does that. Oh, that sucks. That totally is deflating. Why can I indent that way, but I can't indent the other way? It's very frustrating. But I'm not going to let it stop me. Even though it hurts. It does hurt. But it won't defeat me. Okay. So now, if random 0.5 is important equals recover our senses, else is important equals get money. So it will check if this, and then depending on that, it will set what the value of is important, but we have to declare is important. So let is important equal, or just do let is important, and then return this block quote. Let's check this, my knowledge though. I think that's how we make sure it'll be a string. And then report block quote, what's important now is to, and they'll make this a variable, important, and then target there Susan Sontag, and we'll do the author equals Susan Sontag. Well, regardless, I don't want to have to deal with setting up a new link. It's just, we're just testing if this will work. So now we have this function, my quote, that is important as a string. They have this randomness, and so half the time it'll be recover our senses, half the time it'll say get money, and it returns this block quote. What is important now is to that, and then cite Susan Sontag, and we export default my quote. So let's see if this works. So interesting, it's not working. It's always saying recover our senses. Why is that? If math.random is less than 0.5, it is important. We recover our senses. Do we need to import math.? Huh. Can't because of that. Okay. Let's ask Copilot. Why is this never goodness. The issue with your code is that you're trying to use TypeScript syntax in a JavaScript file. Oh yeah, I forgot we're not using TypeScript. In JavaScript, you don't need to specify the type of the variable. The line let is important, string is not valid JavaScript syntax. Here's the correct code. Getting my stuff all mixed up. Let's go. Okay, cool. Now let's try a button. Add elements onto the screen that can respond to events such as clicking or hovering. Make sure to define event handlers for them within the component. So we'll make this an on click, right? So I want to be able to, when I hover this, we'll make it on hover. When I hover this, I want it to change color. So a target blank, strong, on hover equals I'm trying to remember. How could I make it change color on hover? How could I make the link change color on hover? To make the link change color on hover, you can CSS. Seems overly complicated, but I guess the idea is you define these with a link style, so color blue, decoration none, and a hover style, so on mouse enter. All right, I don't got time for all that. Let me just keep pushing forward. So up next. Use create React app to easily create a React application on your own computer. Oh man, I'm starting to get low energy. Absolutely no buckets. Goodness. Okay. Use create React app to easily create a React application on your own computer. Introduction. React is a user interface framework developed by Facebook. It has a quickly growing developer adoption rate and was ranked as the most loved web framework in the 2019 Stack Overflow Developer Survey. This article will walk you through setting up your first React app and assumes you are familiar with text editors and command line navigation. Note, we recommend using Create React app to focus on learning React. You will be able to take what you learn here and apply it to React frameworks like Next.js. Getting ready. We will be using the Node Package Manager (npm), so you will need to have Node installed on your computer. Check if you have Node installed, run this command in your terminal. So let's make this half the screen, and then let us open up the terminal. Let's do npm v, and we have 10.5. If you have Node installed, this command will return a version number like v12.18.1. If it's not already installed, follow the steps to set up Node locally. Oh wait, I did npm, I meant Node. 20.11. When you install Node, you automatically get npm installed on your computer as well. However, npm is a separate project from Node.js and tends to update more frequently. As a result, even if you've just installed Node and therefore npm, it's a good idea to update your npm. Luckily, npm knows how to update itself. To upgrade to the latest version of npm on Nix, so OS X Linux, you can run this command in your terminal. Password. Cool. Setting up the boilerplate application. It is possible to manually create a React app, but Facebook has created a node package, Create React App, to generate a boilerplate version of a React application. Besides providing something that works out of the box, this has the added benefit of providing a consistent structure for React apps that you will recognize as you move between React projects. It also provides an out-of-the-box build script and development server. We will use npx, a package runner tool that comes with npm 5.2 plus and higher, to install and run Create React App. This will ensure that the latest version of Create React App is used. Open up your terminal. If you've previously installed Create React App globally via npm install g Create React App, it is recommended that you uninstall the package first. In your terminal, run these commands. So npm uninstall. I don't think I have it, but let me just make sure. Installed. Cool. Now npx create React app, my first React app. Need to install the following packages. Okay to proceed. Yes. It's so amazing just how simple it is to get started with like something like this. The fact that it's just downloading all the stuff that I need, and also just amazing that I kind of understand what's going on. You know, I've been coding now for, about 1.5 to 2 years, and I didn't know what the F this would have meant. Like back when I first started, I would have been so confused. And now I have some level of understanding, and it's cool to me. I really do view coding and software engineering as having, these complex conversations with a computer, trying to reach a conclusion. And it's very satisfying when you can come to that conclusion and when you can kind of learn the language. And that's why I love learning this stuff. I can sit here for hours and learn about these new ways to speak to the computer, and it's really interesting to me. Happy hacking. Here we go. So if you've never installed Create React App before, you can simply run this command. Just ran that. If you have Yarn, you use it by default. If you prefer to use npm, you can use npm. It will look like this. So npx, we're good though. Feel free to replace my first React app with whatever you want to name, as long as it doesn't contain capital letters. Upon completion, you'll get some quick tips on how to use it. So npm start starts the development server. Npm run build bundles the app into static files for production. Npm test starts the test runner. Npm run eject removes this tool and copies build dependencies, configuration files, and scripts into the app directory. If you do this, you can't go back. We suggest that you begin by typing cd my first React app and npm start happy hacking. Before we run the app, let's take a look around the app structure and see what it contains. So let's do cd my first React app. Now let's open it up in VS Code. Yes. So change directories into the app you just created and open the app in the text editor of your choice. You should see the following file structure. So we have node modules, public with favicon, index.html with some basic information in the header. Oops. Name, description, website created, a link to the icon. Manifest.json provides metadata is used when your app is installed. Manifest, notice these public URLs and tags above are replaced the URL of the public folder. Okay. React app head, body, no script. You need to enable JavaScript to run this app. Div ID root. This HTML file is a template. If you open it directly in the browser, you'll see an empty page. You can add web fonts, meta text, or analyze this file. The build step will place the bundle scripts into the body tag to begin with development. Run npm server yarn start to create a production bundle. Use npm run build body. So cool. That's the index. Have a logo here. 2 logos. Manifest.json with a short name, long name, icons to use, sizes of the icons, type. Another logo. Start URL is the root. Display is standalone. Theme color, background color. Robots, text user agent disallow. I don't know what that's about. We have a source with the app's CSS. We have the app itself, in JavaScript with a function called app, which returns a div class name called app and a header class name header, an image of the logo, and paragraph called edit, source to app and save to reload, class name app link, link, target. So if you click this link, it'll open a new page, no opener, non-refer, learn React, and exports this app. You have app test, which imports render screen from testing and imports app. We test renders learn React link, render app, const link element equals screen dot get by text learn React expect link element. We have this index.css, which sets up the CSS for the index. This index is our main page, so it's importing React DOM, importing index.css, import app, import report web vitals. We have this const root, which is React DOM, so we just set up our root, and then we render the root, which is React strict mode. It's rendering app.js, and in React strict mode, if you want to start measuring performance in your app, pass a function to log results. For example, report web vitals.console.log or send an analytics endpoint. Learn more there. SVG for the logo, reporting web vitals, setting up tests. This git ignore for ignoring our node modules, PNP, and ignore testing stuff, ignore production stuff, ignore these miscellaneous things like any environment variables or DS store and these logs, package.json. These are everything that gets downloaded when we run npm install. Actually, I don't really fully understand the difference between package.json and package log, but I know it has to do with like the packages that we end up downloading, and then this README project bootstrapped with create React app, and this is just stuff on how to get it started, how to test it out and eject it, and some more details. Cool. It's cool that I understand what's going on now for the most part, which I really didn't before, which is why I needed to do this. So where are we at? Okay. React app structure. Change directories into the app you just created and open the app in the text editor of your choice. You should see the following file structure. Create React app has taken care of setting up the main structure of the application, as well as a couple of developer settings. Most of what you see will not be visible to the visitor of your web app. React uses a tool called Webpack, which transforms the directories and files here into static assets. Visitors to your site are served those static assets. Don't worry if you don't understand too much about Webpack for now. One of the benefits of using Create React app to set up your React application. Hold on. Okay. One of the benefits of using Create React app to set up your React application is that we're able to bypass any sort of manual configuration for Webpack. If you're interested in delving deeper into it on your own, you can find a high-level overview of Webpack's core concepts here. So what exactly is Webpack? It's a tool called Webpack to transform your directories. Let's see, is this super long? It's not super long. At its core, Webpack is a static module bundler for modern JavaScript applications. When Webpack processes your application, it internally builds a dependency graph from one or more entry points and then combines every module your project needs into one or more bundles, which are static assets to serve your content from. Learn more about modules in Webpack since version 4, but in our configuration file, dependency graph, anytime one file depends on another, Webpack treats this as a dependency. This allows Webpack to take non-code assets such as images or web fonts and also provide them as dependencies for your app. When Webpack processes your application, it starts from a list of modules defined on the command line or in its configuration file. Starting from these entry points, Webpack recursively builds a dependency graph that includes every module your application needs, then bundles all of those modules into a small number of bundles, often only one to be loaded by the browser. Okay, so reach the limit. I'm learning React. Give me a brief but understandable explanation of what Webpack is and how it relates, and focus on a practical explanation that will help me understand what's happening as I'm building a React website. Okay, sure. Webpack is a static module bundler for modern JavaScript applications. Okay, it's just it's just grabbing it. So in the context, Webpack has a couple main roles. It bundles it. Webpack takes all of your JavaScript files and other assets like CSS and images and bundles them into a single or few output files. This not only ensures that modules and libraries are loaded in the right order, but also reduces the number of HTTP requests, improving the app's performance. Transpiling. React code is often written in ES6 syntax, which is not fully supported in many browsers. Webpack, with the help of Babel, transpiles this code into ES5 syntax that is widely supported by current browsers. Hot module replacement. This is a feature that allows you to make changes to your React components in real time and see the results instantly without refreshing the page. Code splitting. This feature allows you to split your code into various bundles, which can then be loaded on demand or in parallel. This can significantly improve the performance of your application. In summary, Webpack is a powerful tool that optimizes your React application for development and production. It helps manage dependencies, optimize performance, and provide a smooth developer experience. Cool. So, git ignore. This is the standard file used by the source control tool Git to determine which files and directories to ignore when committing code. While this file exists, Create React App did not create a Git repo within this folder. If you take a look at the file, it has taken care of ignoring a number of items, even .dsstore for Mac users. And package.json. This file outlines all of the settings for your React app. Name is the name of your app. So go to package.json. So name is the name of your app. Version is the current version. Private true is a fail-safe setting to avoid accidentally publishing your app as a public package within the NPM system. Dependencies contains all the required node modules and versions required for the application. In the picture above, you'll see 6 dependencies. The first 3, as you may have guessed, are for the purpose of testing. The next 2 dependencies allow us to use React and React DOM in our JavaScript. Finally, React scripts provides a useful set of development scripts for working with React. In the screenshot above, the React version specified is 16.13.1 and above. Here, we have 18.2 and above. This means that NPM will install the most recent major version, matching 16xx. In contrast, you may also see something like, what's this called again? I forget, squiggle 1.2.3 in package.json, which will only install the most recent minor version matching 1.2.x. Script specifies aliases that you can use to access some of the React scripts commands in a more efficient manner. For example, running npm test in your command line, or run React scripts test env equals JS DOM behind the scenes. I'm a little bit confused by that. Specifies aliases. So we have start, React scripts start, build, React scripts build, test, React scripts test. So it's just some scripts, aliases that you can use to access some of the React scripts commands in a more efficient manner. For example, running npm test in your command line will run. Okay, so we just need to run npm test and it'll automatically run React scripts test for us. Got you. So you will also see 2 more attributes, ESLint config and browsers list. Both of those are node modules having their own set of values. Browsers list provides information about browser compatibility of the app. So we see production greater than 0.2%, not dead, not OP mini, all. I don't know what that means. Development, last one, Chrome, Firefox, and Safari. And then we see ESLint takes care of the code linting, which is like, you know, the style of making sure that you're coding in a way that is up to other people's standards so that your code is readable. Node modules. This directory contains dependencies and sub-dependencies of packages used by the current React app. as specified by package.json. If you take a look, you may be surprised by how many there are. Running ls-1 pipe wc minus l, or I don't know, that's a hyphen, regardless, within the node modules directory will yield more than 800 subfolders. This folder is automatically added to the .gitignore for good reason. Don't worry, even with all these dependencies, the basic app will only be around 50 kilobytes after being minified and compressed for production. What does this mean? In computer science, minification is the process of removing unnecessary elements, rewriting code to reduce file sizes, commonly done to web page resources. Reducing the size of web resources allows the files to be transferred more quickly, making them load faster. There are several ways to modify data. Most basic is to remove comments, unnecessary spaces, and line breaks, new line characters, while comments and white space help make the code more readable. They are ignored by the browser, therefore these elements can be safely removed before publishing. Another method is to minimize the code required for each statement. In CSS, this is often accomplished by converting longhand CSS to shorthand CSS. For example, a margin definition might take several lines in longhand, but only one line in shorthand. In JS, long variable names can be replaced with shorter ones, often a single character. Below is an example of CSS code before and after modification. Note how the comment spaces, line breaks, and unnecessarily semicolons are removed. The code is also converted to longhand CSS. So this is image.left, comment letting it know that we're floating left 400 pixel image, float left, all this stuff, but modified just makes it all condensed. Okay, makes sense. Modification versus compression. So best modification allows to reduce file size even further. CSS modifier, for instance, if I remove duplicate lines within the CSS file, may also combine similar CSS definitions into a single statement. A JS modifier may actually rewrite JavaScript functions to be more efficient. Modifying code often saves only a few kilobytes. For example, a standard CSS file may be 50 kilobytes and the modified version may be 40 kilobytes. However, when improving page load speed, every kilobyte matters. The goal of a good modifier is to reduce file sizes as much as possible with zero impact on the way the code is parsed or processed. Regardless of what modifier is used, developers typically maintain a non-modified version of the code for future editing. Modification versus compression. While modification and file compression both reduce file size, they are not identical. Modification simply alters the text, while compression completely rewrites the binary code within a file. A compressed file must be decompressed by file decompression utility in order to be read as a text file. Many websites use a combination of modification and gzip file compression to reduce the size of web resources as much as possible. Interesting stuff. So the app will only be around 50 kilobytes after being modified and compressed for production. So cool. Package lock.json. This file contains the exact dependency tree installed in Node modules. This provides a way for teams working on private apps to ensure that they have the same version of dependencies and subdependencies. It also contains a history of changes to package.json, so you can quickly look back at dependency changes. Public. This directory contains assets that will be served directly without additional processing by Webpack. Okay, let's check it out. Public. So, index.html provides the entry point for the web app. You will also see a favicon, header icon, and a manifest.json. So this is our basic HTML. This is our header icon, and this is the manifest.json. The manifest file configures how your web app will behave if it is added to an Android user's home screen. Android users can shortcode web apps and load them directly from the Android user interface. You can read more about it here. Source. This contains the JavaScript that will be processed by the Webpack. So, okay, so icons. Okay. Yep, so source. This contains the JavaScript that will be processed by the Webpack and is the heart of the React app. Browsing this folder, you see the main app JavaScript component, app.js, its associated styles, app.css, and test suite, app.test.js, index.js, and its styles, index.css. Provide an entry into the app and also click off the register service worker.js. This service worker takes care of caching and updating files for the end user. It allows for offline capability and faster page loads after the initial visit. More of this methodology is available there. I didn't really let that sink in, so I'm going to read it again. At least, browsing this folder, you see the main app JavaScript component, app.js. Its associated styles, app.css, and test suite, app.test.js, index.js, index.js and its styles, index.css, provide an entry into the app and also kick off the register service worker.js. Where is that at? This service worker takes care of caching and updating files for the end user. It allows for offline capability and faster page loads after the initial visit. More of this methodology is available here. What is that? Register service worker. Maybe they've changed the name. Yeah, it looks like report web vitals is now what they're talking about when they say register service worker. Because we have app test, index CSS, logo, and then report web vitals instead of service worker, but we still have setup tests. I don't need to look at that right now. As your React app grows, it is common to add a components directory to organize components and component-related files, and a views directory to organize React views and view-related files, starting the React app development server. As was stated in the success message when you ran create React app, you just need to run npm start in your app directory to begin serving the development server. It should auto-open a tab in your browser that points to localhost 3000. Okay, so npm start. Cool. As stated, any changes to the source code will live update here. Let's see that in action. So what I'm going to do is, how do I organize this? I think what makes the most sense, put that right there, make it a little shorter, and bring this down here. So let's see it in action. Leave the current terminal tab running. It's busy serving the React app, and open source app.js in your favorite text editor. So source app.js. You'll see what looks like a mashup of JavaScript and HTML. This is JSX, which is how React adds XML syntax to JavaScript. It provides an intuitive way to build React components and is compiled to JavaScript at runtime. We'll delve deeper into this in other content, but for now let's make a simple edit and see the update in the browser. Change the main paragraph text to read Hello Codecademy. In app.js, save the file. So the main header text, change the main paragraph text, paragraph. So right now it says edit source/app.js and save to reload, but we're going to take this and change it to read Hello Codecademy. Cool. And they're interesting that it's not importing React from here, but most of it looks the same other than that so far, at least. Return div class name, header class name app header, image source logo, class name app logo, alt logo, Hello Codecademy, class name app link, href, blank for target, rel no open or refer, learn React, close them. Cool. So most of it's the same. If you left the terminal running, you should be able to switch over to your browser and see the update. Congratulations, you're now up and running with React. You can now begin adding functionality to your application. Next steps. If you'd like to learn more about Create React App, start with the documentation on the Create React App website. Since an important next step after creating a React app is to set up your environment and to debug it, consider checking out our React Developer Tools article. There we use the initial skeleton created with React App to get you ready to begin debugging React apps. Maybe that's what I should check out, but I don't know, this is just so much. Okay, let's see what's next. Skip the project and the test for now. So, let's see what this is about. Components interact. A React application can contain dozens or even hundreds of components. Each component might be small and relatively unremarkable on its own. When combined, however, they can form enormous, fantastically complex ecosystems of information. In other words, React apps are made out of components, but what makes React special isn't the components themselves. What makes React special is the ways in which components interact. This lesson is an introduction to components interacting. After this lesson, you should be familiar with how components can reference other components, how this allows us to separate our components into separate files. So here we have the app, it's the top, this is the root, we have a search bar, and our React can go to post something. Our app can go to post, maybe user info, content, reactions, options, like, comment, share status. So let's keep it pushing. Returning another component. As we've seen before, each React component is responsible for one piece of the interface. As the application grows in complexity, components need to be able to interact with each other to support the features needed. So far, we've explored components that return JSX elements, such as function purchase button, return button on click, sends an alert, purchase complete, purchase button. In this example, the React component is not interacting with other components. However, you can have components interact with each other by passing information or even returning other components. So here we see function, purchase button, return button on click, alert purchase complete, purchase button, function item box, return div, h1, 50% sale, h2 item. So essentially we have this function called purchase button. When this function activates, we return a button on click that says purchase, and on this, or we turn a button that says purchase, and on click it has an action where we get an alert that says purchase complete. We have another function called item box, which just returns a div with a header that says 50% sale and a subheader that says item small shirt, and then has the purchase button in it. So in this example, the React component is not interacting with other components. However, you can have components interact with each other by passing information or even returning other components. In the above example, item box returns an instance of purchase button. This is an example of how, snap, I didn't mean to do that. This is an example of how a component can reference other components. View profile.js and observe how the picture component is referenced inside of the profile component. So here we see function picture, which returns an image with this source, and we have this profile, which returns a picture, and then a header, a subheader, and another subheader. Reference side picture is responsible for a piece of profile together. So picture component is referenced inside of the profile component. Picture is responsible for a piece of profile. Together, we exported only the profile component to be rendered. Cool. Apply component in a render function. You may have noticed that you've seen this behavior before. In the previous lessons, when we defined components and exported them, we usually exported them into our top level file, app.js, inside app.js. Pay attention, let it sink in. Okay. Apply a component in a render function. You may have noticed that you've seen this behavior before. In the previous lessons, when we defined components and exported them, we usually exported them into our top level file, app.js. Inside app.js, we imported components and returned them inside our app component, which are then exported to be rendered. So here we see import button from button, and the function is app, which returns button. We export default app. Look familiar? This ability allows us to separate components into smaller functions and connect them together to make more complex components. We can treat it as the button component is a child of the parent app component. By breaking a component into extracted, smaller components, we can reuse the individual parts when necessary. The code editor has two files, profilepage.js and navbar.js. Complete the profile page component by having it return a navbar. So here we see this profile page function, which returns a div, which has h1 all about me, p I like movies, and blah blah blah, an image, and end the div. So what we need to do is import this navbar. So navbar has pages, home, blog, pics, bio, art, shop, about, contact, and it has nav links is pages.map. So we're mapping each page in pages to this returned anchor, which has href / plus page. So it's gonna create a link essentially to each page for each page within pages, and a reference looks like nbsp page. I don't fully understand what that means, but essentially this function navbar is breaking down our pages list into a bunch of different nav links and returning them as a nav element, which would contain a bunch of anchors that have links to each page. we're exporting this. So I think we need to import it. Yeah, import. That's the right way to import. Import navbar. What is happening? Import nav bar from navbar. And so now we just add navbar. Complete the profile page component by having a return a navbar component above h1 about me. Now we can see the navbar right there. Don't forget to import the necessary component. Review. Great job. You've reached the end of this brief but important lesson. Let's recap. A React application can contain multiple components. Components can interact with each other by returning instances of each other. Components interacting allows them to be broken into smaller components, stored into separate files, and reused when necessary. If you want to practice your skills, use what you've learned about components interacting to create a page from scratch. In the code editor, we've provided 3 files, app.js, index.js, and helloworld.js. Render a hello world greeting onto the screen with the appropriate file structure, where app.js contains the top level component and index.js renders it. If you're stuck, view the hints on what should be included in each. So, again, we're going to create a page from scratch here. In the code editor, we have 3 files. We have app.js, which again is like the top level. Index.js is the entry point that people really see. And hello world is going to, seems like we're going to need to, it's going to be a component. So render a hello world greeting onto the screen with the appropriate file structure. So first of all, import React. I think it's from React. Is that right? Import React from React, yeah. So import React from React. Import document object model from React. DOM/client. So that's our imports. And then function, right? We need to display something on the screen. So in order to display something, we need to, set up the root. So const root equals React DOM. Create root. And we're going to do that with document dot get element by ID. The ID is app, typically. That's what we've been using so far. So, but document, yep, got it right. How did that happen? I'm not talking to anybody, am I? I don't know what that noise is about. Sorry, you probably can't. You don't even know what I'm talking about. So, set up the root. Render the root. So, root render, and we could say for now let's just render something to get something on the page. World. Not seeing it on the page. Doing something wrong. root.render. I think I'm doing everything right. I don't know why it's not rendering though. Regardless, oh, we don't have the app. So first of all, import React from React. And at some point we're going to want to import, well, first let's create this hello world component. So define world header. So function hello world just returns turn h1 hello world. And export default hello world. Now we can import hello world from hello world, and I guess function to use hello world component would be something like mine's going blank a little bit. Wake up, wake up, wake up. So at some point we're gonna need to import app from app. Ultimately what we want is just to be able to render this app. And I know at some point export the app. Export default app. So we're going to need a function called app. And in this function, what's going to happen? It's going to, I'm going to create a div. I think I might have to assign it to something. Can't remember if I have to assign it or how it works again, but for right now, let's just say since we're importing hello world, we can put the hello world at the top. Hello world. And also put a paragraph in there. Learning React is interesting. And okay, I'll do that for now. That's it. It's our function. So when this gets exported, it's going to export this chunk into what we render. It's pulling hello world from here. I feel like I mean, why would I necessarily, what do I need to import here? I'm not even sure. Let's see what happens if I run this. Nada. Okay, let's go check out this create React app to see what I'm blanking on. So right, if we start it here, so a function which is returning something, that would probably be a good first step, right? If our function actually returns something. I like that idea. Okay, first of all, let's indent this. Let's create this return. Is this returning? Yeah, okay. What happens if we run it now? Okay, so function returns some stuff. This looks right. React DOM, React app, const root, root.render, and then I don't think we should need, I mean, I guess we could just add it just in case. I didn't think we'd need to import React for the hello world though, but let's find out if that makes it work. Still isn't working. Maybe I want to delete that. So import the React model to use JSX. Yep, imported React. Sorry, this is hello world. Define a hello world function. Component that returns an H1 with a greeting. Export the hello world component. Done. App.js. Import the React module to JSX. Import the hello world to use the component. Define an app function. Component that returns an instance of the hello world component. Export the app component, and then index.js. Import the React module to use JSX. Import DOM to render elements. Import app top level component. Use create root to specify container to render the elements in and render the app component. And I think that's index const root. What's the HTML file? App. Yeah, it should be app. I don't know. I think that this is bunk. It's not my fault. I really gotta pee, so break time. Okay. Check 1 2, check 1 2. We're good. Still streaming. 1 2 1 2. Audio looks good. Cool. So, props. When thinking in the frame of a React application, components are small pieces of a whole. Together they make up the interface that users will see, with each component playing a role in the interface. There are times when components must be able to communicate with other components. In this lesson, you will learn another way that components can interact, a component passing information to another component. Information that gets passed from one component to another is known as props. Props can be used to customize the output of each component depending on the information that is passed in. By allowing components to communicate with each other, we can add a level of flexibility that was not possible before. By the end of this lesson, you should be able to pass, access, and display props, use props to create conditional statements, define event handlers in a component, and pass them to other components, work with the component's children, assign default values to props. Let's get started. Let me let that sink in a little bit more. So, props. When thinking in the frame of a React application, components are small pieces of a whole. Together, they make up the interface that users will see. With each component playing a role in the interface, there are times when components must be able to communicate with other components. In this lesson, you will learn another way that components can interact, a component passing information to another component. Information that gets passed from one component to another is known as props. Props can be used to customize the output of each component depending on the information that is passed in. By allowing components to communicate with each other, we can add a level of flexibility that was not possible before. By the end of this lesson, you should be able to pass, access, and display props, use props to create conditional statements, define event handlers in a component and pass them to other components, work with components' children, and assign default values to props. So again, pass, access, and display props, use props to create conditional statements, define event handlers in a component, and pass them to other components, work with the component's children, assign default values to props. Let's get started. In this video, you can see different components interacting with each other with a top to bottom data flow. The post component passes a prop, a piece of information, to the content component. The prop contains a string, images, atom.png, which is used to display the image. Access a component's props. Every component has something called props. A component's props is an object. It holds information about that component. You've seen this before, but you might not have realized it. Let's take a look at an HTML button tag. There are several pieces of information we can pass to the button tag, such as the type of the button. Here we see a button with type submit. In this example, we've passed two pieces of information to the button tag, a type and a value. Depending on what type attribute we give to the button element, it will treat the form differently. In the same way, we can pass information to our own components to specify how they behave. Props serve the same purpose for components as arguments do for functions. To access a component's props object, you can reference the props object and the dot notation for its properties. Here's an example, props.name. This would retrieve the name property from the props object. Look at props_displayer.js. This component has props as part of its parameter. So here we see import React function props displayer, which takes in props const string props equals JSON stringify props. So it takes in props, which should be a JSON object, and makes it a string, and returns div check out my props object h2 div export props displayer. I feel like string props needs to be put in there somewhere. So look at props displayer. This component has props as part of its parameter. Inside the function body, there is a string props variable which contains the string data of props. Let's display it on the screen and see what's inside by injecting the string props variable between the h2 tags. So string props, nothing. Now that we finished the props displayer component, let's use it in our top level component app and have it rendered to the screen. Open up app.js, open up app.js, take a look at the app component definition. So app, import props displayer from props displayer, and have it return the props displayer component. So and rendered. Where is it even getting props from though? I don't see an import of props. Function props displayer, clear string props. Confusion. Click run and then think about what you see. If you're seeing an empty object, you're on the right track. Okay, yeah, because props doesn't exist right now. The props object isn't really empty. It has some properties that JSON stringify doesn't detect. But even if you could see those properties, the props object still wouldn't have much to show you right now. Keep going and see what else we need. Pass props to a component. To take advantage of props, we need to pass information to a React component. In the previous exercise, we rendered an empty props object because we did not pass any props to our props displayer component. How do we pass props? By giving the component an attribute, greeting, name, Jamil. Let's say that you want to pass a component the message "we're great." Here's how you can do it. So slogan display message equals "we're great." As you can see, to pass information to a component, you need a name for the information that you want to pass. In the above example, we use the name message. You can use any name you want. If you want to pass information that isn't a string, then pass that information in curly braces. Here's how you would pass an array. You do greeting my info, and in curly braces we have this array astronaut Narek 43. In this example, we pass several pieces of information to greeting. The values that aren't strings are wrapped in curly braces. So greeting name, Queen Mary, city Long Beach, California, age 56, haunted, curly, true. Cool. So inside the app top level component, find the line where we call the props displayer component. Modify this line so that props displayer is called with the prop name myProp and the string value hello. So I'm gonna send it myProp equals hello. So now will we see something cool? myProp hello. It's cool. Render a component's props. Props allow us to customize the component by passing it information. We've learned how to pass information to a component's props object. You will often want a component to display the information that you pass. To make sure that a function component can use the props object, define your function component with props as the parameter. So here we see function button props, return button props.display text button. In the example, props is accepted as a parameter. So props, so we have this function button props, we're returning button, and here we have props.display text. We're taking the display text from whatever we're passing to this function. So again, props allow us to customize the component by passing it information. We've learned how to pass information to a component's props object. You will often want a component to display the information that you pass. To make sure that a function component can use the props object, define your function component with props as the parameter. In the example, props is accepted as a parameter, and the object values are accessed with the dot notation accessors pattern, object.property name. Alternatively, since props is an object, you can also use destructing syntax like so. Function button display text, returning button display text button. Instructions: explore the code in the code editor. Product.js contains the outline of a component responsible for displaying the products of an e-commerce site. So here we see function product, which returns this div with header, subheader, and a subheader div, and exports product to app.js, which is importing product, has this function app, which returns product name, product object with a name, Apple Watch, a price $3.99, and a rating of 4.5 out of 5, and exporting the app. So app contains the top level app component, which calls the product component with 3 pieces of information: name, price, and rating. However, the product component does not accept props. In product.js, modify the product component so that it accepts props in the function definition. So I guess, can we call a prop anything? Because here's what I would want to call them, what they actually are, right? So name, price, and rating. Props as an argument, okay. Has to be called props. Next, display the name of the product in the h1 tag by injecting the name value from props. So it'll be props.name. For the h2 tag, inject the price value from props. So props.price. And then finish it off by injecting the rating value from props within the h3 tags. So props.rating. In app.js, test out your code by tweaking the value of name. So if we tweak the value Apple, we'll call it the Mac Mini, and make it that much. Cool. Click run once the browser refreshes. New information about a product should appear on the screen. Pass props from component to component. You've learned how to pass a prop to a component. Greeting, first name Esmeralda. You have also learned how to access and display a passed-in prop. Return h1 props.firstName. The most common use of props is to pass information to a component from a different component. Props in React travel in a one-way direction from top to bottom, parent to child. Let's explore the parent-child relationship of passing props a bit further. So here we have function app, return product name, Apple Watch, price $3.99, rating 4.5 out of 5. In this example, app is the parent and product is the child. App passes 3 props to product, name, price, and rating, which can then be read inside the child component. Props passed down are immutable, meaning they cannot be changed. If a component wants new values for its props, it needs to rely on the parent component to pass it new ones. Let's practice this. Your mission is to pass a prop to player from app. Ensure that player can accept props by changing the function definition to include props in the parameter. So here props, and we're going to pass it what? So pass a prop to player, turn player, and I don't know, it's so music player. And we'll do song equals party rock anthem. And then we'll do props dot name. Oh, here actually, I'll do song party rock anthem, and artist equals LMFAO. So this will take props dot song, and this will take props dot name, artist. Oh, we're not exporting this. Next, display the name of the song in H1 by injecting song name value from props. Oh, but I gotta call it song name. All right, song name. Display the name of the artist in the H2 tag by injecting the artist value from props. Already done. Looks cool. I like that font. Since app is passing props to player, app is the parent and player is the child. Inside the player.js, export the component to be used in app.js. Open app.js, import the player component in app.js. In the app component, call the player component with the attribute song name, giving it a string of your favorite song and the artist of the song. This is not my favorite song, but it's a good song. I'm not mad at it. Next, render different UI based on props. You can do more with props than just display them. You can also use props to make decisions. Function login message props. If props.password is equal to a tough password, return h2 sign in successful. Else return h2 sign in failed. In this example, we use the props passed in to make a decision rather than rendering the value to the screen. If the password received is equal to a tough password, the resulting message in h2 will be different. The passed in password is not displayed in either case. The prop is used to decide what will be displayed. This is a common technique. Again, let it sink in. Render different UI based on props. You can do more with props than just display them. You can also use props to make decisions. So in this example, we use the props passed in to make a decision rather than rendering the value to the screen. The props come in. If the props password is a tough password, then this login message will return sign in successful. Else, if props.password is not a tough password, then we're going to return sign in failed. So we're just using the props to make a decision rather than rendering their value to the screen. If the password received is equal to a tough password, resulting message in h2 will be different. The passed in password is not displayed in either case. The prop is used to decide what will be displayed. This is a common technique. Select greeting.js. Look in the function component definition. You can see that greeting now expects 2 props, name and signed in. So if props.signed in, And we also have props.name over here. So if props.signedin is false, so if they're not signed in, then return please log in, else return welcome back, name, article, latest movie, a computer bugs life. But greeting, this means like greeting. So notice that props signed in is not located inside of a return statement. So if props it's not signed in, but greeting. This means that greeting will never display the value of signed in, but greeting will use that value to decide which message to display. Look at greeting until you feel like you understand how it works, and then open app.js. So greeting, so again, if the props signed in, then false, return please log in, otherwise return hi, welcome back, your name, and then an article, latest movie, a computer bugs life. So movie flicks, welcome back, Allison, latest movie, computer bugs life. Look at app.js, give the greeting component, additional attribute of signed in with the value of false. So name Allison, signed in equals I think it has to be, yeah. In app.js, change the value of signed in to make greeting display a friendly greeting. Nice. Put an event handler in a function component. You can and often will pass functions as props. It is especially common to pass event handler functions. In the next exercise, we will pass an event handler function as a prop. However, we have to define an event handler before we can pass one anywhere. In this exercise, we will define an event handler function. How do we define an event handler in React? We define an event handler as a method on the function component. Take a look at the example.js file in the code editor on lines 4 through 8, right here. An event handler method is defined. So we have this function example. Within it, we have this function event handler. With an alert, I'm an event handler. If you see this message, then I've been called. We return h1 on click, handle event, but it's not doing anything right now because this is not being exported. On line 10, that event handler method is attached to an event. Line 10, on click, handle event. Attached to an event. Click event in this case. So select talker.js. Here we have a function named talk that alerts 10,000 blahs to your screen. So let speech is a empty string for right now. And then for let I equals 0, I is less than 10,000, I plus plus, speech plus equals blah. So we add that and we create an alert of speech of 10,000 blahs. There's a problem. Talk is defined outside of the talker component. Here we have this function talker returns a button. This button. Rewrite talk so that it is a method defined inside the talker component. Look at example.js if you get stuck. So we're going to take this, copy it. Didn't copy the F, copy that. This indentation needs to be fixed. So that's this function. And then we return a button, which takes a on click equals talk. I believe that's right. Even if it's not, let me take the pain of being a dummy and see what happens. Oh, it is. Maybe, possibly. No. No, it's not working right. Delete the original. Oh, so here we have a function named talk that alerts 10,000 blahs to your screen. You will eventually use talk as an event handler. There's a problem. Talk is defined outside of the talker component. Rewrite talk so that it is a method defined inside the talker component. Look at example. If you get stuck once you're done, delete the original talk function before clicking run. So here, import button from button and return button on click equals talk. A little confused why it's not working actually. Export default talker. Let's see. The talk function should be inside. I understand that. So you're trying to pass the talk function as a prop to the button component, but you're not actually setting it as an event handler. React event handlers need to be passed in curly braces. So here, function talker talk. Thought I was passing it as an event handler. So function talk, let speech for I, this, speech plus equals blah, alert speech. So this function talk, and then, oh yeah. Return button on click talk. Is that not what's the difference? I genuinely. So import React from React. So top two lines are exactly the same. Function talker, exactly the same. Function talk, exactly the same. Let speech, exactly the same. For let I equals 0, I less than, so that's exactly the same. Speech plus equals blah, exactly the same. Alert speech, exactly the same. And then return button on click equals talk. These are exactly the same, are they not? Yeah, it's the same. Maybe it's not on click, huh? No, it is on click. I don't know, man. Maybe this is just Codecademy tweaking out. I don't know why it's not working, but I feel like I have a decent understanding of the concept. So let's keep it pushing. Pass an event handler as a prop. Good. You've defined a new method inside the talker component. Now you're ready to pass that function to another component. You can pass a method in the exact same way that you pass any other data using curly braces. Select talker.js. You want to pass talk from here to button. To pass a prop, you need to give button an attribute. Let's start there. Inside talker's return statement, give button the following attribute, foo bar. So I guess the fact was that button just didn't have a way to accept what we were trying to do. So first of all, button props. You want to pass talk from here to button. To pass a prop, you need to give button an attribute. Let's start there. Inside talker's return statement, return, give button the following attribute, foo. I don't know what this means, and I see it in a bunch of coding tutorial stuff, and I gotta know. See these phrases, foo bar, in a lot of coding tutorials. What is their significance? The terms foo and bar are often used as metasyntactic variables in computer programming. They are placeholders, names for variables in coding and programming. Here's a bit more detail. Placeholder names, but illustrating concepts without getting caught up in thinking about specific variable names. Programmers use foo and bar. They don't really mean anything as words and are just used in place of a more accurate name, generally for purposes of convenience. You'll encounter foo and bar in manual pages. They're using programs want to illustrate concepts without getting too caught up. It is possible that foo bar is a playful allusion to World War II era military slang foo bar, fucked up beyond all recognition. The first known use of the terms in print in a programming context appears in a 1965 edition of MIT's Tech Engineering News. In summary, they're convenient and they don't really mean anything, but they might talk about people being fucked up beyond all recognition from World War II. That is a crazy origin story. So, Good. You've defined a new method inside talk component. So it's like you want to pass talk from here to button. To pass a prop, you need to give button an attribute. Let's start there. Inside talker, in talker's return statement, give button the following attribute foo. That's crazy. That's what that means. During the next two checkpoints, to replace these values with the values that you need. Keep them as foobar for now. I kind of went from hating it to kind of loving it, but also just confused. Your goal is to pass talk from talker to button. What prop name should you choose? So, see, I'm at the point now where I'm like, I gotta go hit the gym and kind of get a refresher because my energy is dead. But let's finish out this section. So, what prop name should you choose? It really doesn't matter. Prop attributes will work with just about any name, so long as the name follows the JavaScript identifier rules. Since you're going to pass a function named talk, you might as well use talk as your name. Inside the return statement, change your attribute name from foo to talk. So, talk. What should your prop value be? Your prop value should be the information that you want to pass. In this case, you want to pass the method named talk. Inside the return statement, change your attribute's value to talk. Remember to use curly braces to pass in talk as JavaScript. Still isn't working. Receive an event handler as a prop. Great, you just passed a function from talker to button. Take a look at button.js in the code editor. Import React from React, function button, takes in props, returns button, click me. Export default button. Take a look at button. So notice that button returns a button element. If a user clicks on this button element, you want your passed in talk function to get called. This means that you need to attach talk to the button element as an event handler. So I think, I'm just gonna guess here, and I might be wrong, but I'm willing to be wrong. Props.talk as an event handler. How do you do that? In the same way that you attach any event handler in JSX element, you give that JSX element a special attribute. The attribute's name should be an event name like onClick or onHover. The attribute's value should be the event handler that you want to attach. In button.js, add an onClick attribute to the button element in the return statement. Remember that you named your prop talk previously. Use the talk property of props as the value of the onClick attribute. Click run. Once the browser refreshes, click on the button. So let me make sure I'm not just making stuff up, right? So we need to call this props. And the props that it's getting is this. Talk equals talk. So we're sending it props.talk. I believe this is correct. And this should work. Beautiful. Beautiful, beautiful, beautiful. Handle event, on event, and props.onEvent. Let's talk about naming things. When you pass an event handler as a prop, as you just did, there are two names that you have to choose. Both naming choices occur in the parent component, the component that defines the event handler and passes it. The first name that you have to choose is the name of the event handler itself. Look at talker.js, lines 5 through 11. So this is 5 through 11. This is our event handler. We chose to name it talk. The second name that you have to choose is the name of the prop that you will pass, that you will use to pass the event handler. This is the same thing as the attribute name. For our prop name, we also chose talk, as shown on line 12. Talk equals talk. These two names can be whatever you want. However, there is a naming convention that is commonly used. Here's how the naming convention works. First, think about what type of event you are listening for. In our example, the event type was click. If you are listening for a click event, then you name your event handler handle click. If you are listening for a hover event, then you name your event handler handle hover. So a function in my class would have a function handle hover, and the alert would be I am an event handler. An alert will be I will be calling a response to hover events. Your prop name should be the word on plus your event type. If you are listening for a click event, then you name your prop on click. If you are listening for a hover event, then you name your prop on hover. So handle hover, this function returns these alerts, and we return this. So child on hover equals handle hover. So in talker.js, change the event handler's name from talk to handle click. Because what we're doing is, if you're listening for a click, in talker's return statement, change the prop's name from talk to on. Hold on. Sorry, just whatever, I'll ignore it. To on click. Change the prop's value to the newly named event handler, handle click. Wait. Okay. Change the prop's value to the newly named event handler. So prop focus. In talker's return statement, change the prop's name from talk to on click. Change the prop on click. Change the prop's value to the newly named event handler, handle click. Select button.js. Change button's return statement so that it expects a prop named on click instead of talk. So this is on click equals props on click. One major source of confusion is the fact that names like on click have special meanings, but this is only if they're used on HTML-like elements. Look at button.js. When you give the button element an attribute named on click, then this on click attribute has a special purpose. As you've learned, this special on click attribute creates an event lister that listens for clicks on the button element. So in button.js, on click attribute creates an event handler, button on click, props.on click. Click me. Now look at talker.js. Here, the on click attribute you gave to button does not create an event handler. This is not creating an event handler. All this is doing is creating something to pass, right? It's just the name of an attribute. That's it. So in talker.js, the on click attribute is just a normal attribute name. So button on click is this function. And we're passing this back as a prop to here when we call it. Yeah, I'm confused. This makes sense that this is confusing. So the reason for this is that button is not an HTML-like JSX element. It's a component instance. Names like onClick only create event listeners if they're used on HTML-like JSX elements. Otherwise, they're just ordinary prop names. Run your program to ensure that your button is working as intended. So, is something wrong? No. Button is working as intended. Props.children. Every component's props object has a property named children. Props.children return everything in between a component's opening and closing JSX tags. Again, every component's props object has a property named children. Props.children will return everything in between a component's opening and closing JSX tags. So far, all of the components that you've seen have been self-closing tags, such as myFunctionComponent. They don't have to be. You could write myFunctionComponent, and it would still work. Props.children would return everything in between myFunctionComponent and closing myFunctionComponent. By using props.children, we can separate the outer component, myFunctionComponent in this case, from the content, which makes it flexible and reusable. Look at BigButton.js. In example one right here, Big Button, I am a child of Big Button. In example one, Big Button's props.children would equal the text, I am a child of Big Button. In example two, Big Button, Big Button's props.children would equal little button component. This little button component. In example 3, Big Button's props.children would equal undefined. If a component has more than one child between its JSX tags, then props.children will return those children in an array. However, if a component has only one child, then props.children will return the single child not wrapped in an array. Select app.js. Notice that app renders two list instances. So here we see function app, which is returning a div, which has list type equals living musician, Sachiko M, and a list item Harvey Sid Fisher, and then another list type living cat musician, which has a list item Nora the piano cat. List close, div close, and export default app. Now open list.js and take a look at the list component. So this function list props let title text equals favorite props dot type. So it takes props dot type. So living musician. So title text equals favorite living musician. It's taking that from there. If props dot children instance of array title text plus equals s. So if props dot children is an instance of array title text plus equals s. So it's pretty much saying, so if props dot children is an array, then add an s to there, because that would mean that there's multiple things in here. Now open list.js, take a look at the list component. Think about the fact that each list instance is going to be rendered with 2 JSX tags. So this list opening tag, list closing. We know this because this, okay? And that there will be at least one list item child in between those tags. Click run. You can see 2 list titles in the browser, but no list items. How can you make the list items appear? Open list.js in the return statement of the list component in between ul tags, add props.children. So lists in the return statement between these, add props.children. Returning this, so function is list, let title, if props.children, so returning div default list, and this app is returning all of this. It's using these list items. And again, the list item sets the title text to whatever we put in here, and it sets it organizes it as a header and then an unordered list depending on the children that we put in here. So optional task, each list instance is passed a singular title, living musician and living cat musician, respectively. Somehow each list counts its list items and automatically adds an s to the end of its title if the count is greater than 1. We could add a second piano cat and the second list title would automatically pluralize. See if you can figure out how the instances of the list component class are automatically pluralizing their titles. Well, like I said, they're checking the children, and if it's an instance of array, which means that there's more than one thing between the opening and closing tag, then it adds the s. So if we were to come in here and add another list item, favorite cat, living cat musician, we'll make it, I don't know, rap cat. And now this should have a S and it should show rap cat. Cool. Giving default values to props. Take a look at the button component. Notice that on line 6, button expects to receive a prop named text. So button expects to receive a prop named text. The received text will be displayed inside of a button element. What if nobody passes any text to button? If nobody passes any text to button, then button's display will be blank. It would be better if button could display a default message instead. If you can make this happen by specifying, a default value for the prop. Sorry, this is a distraction. Okay. You can make this happen by specifying a default value for the prop. There are 3 ways to do this. The first method is adding a default prop static property to the component. So function example props, return h1 props.text, example.default props equals text. This is default text. You can also specify the default value directly in the function definition. So what you could do is function example, and in there put a text equals this is default text, return h1 text. Lastly, you can also set the default value in the function body, const example props, function example props const text equals this is default text equals props. So you assign props to this and it overrides it. But if props is blank, then it would just be this is the default text. In an example, if an example doesn't get past any text, then it will display this is default text. If an example does get past some text, then it will display that past some text. In button.js, give the text prop a default value. Set the default value to default text of big button, then retrieve the text prop between the button tags run your code. So which one do I like the best? I feel like I guess I like this one. So button dot default props equals text. What does it need to say? Default text of big button. Do we need a semicolon? Yeah, I think so. No, we don't. Okay. Then retrieve the text prop between the button tags. What do you mean retrieve the text? Retrieve the text prop between the button tags. So, return button props. So, retrieve the text prop between the button tags. Run your code. No, I'm doing something wrong, aren't I? Yeah. Oh no, I'm not. Cool. Because I'm importing React to this function button props, and this function returns a component which has this props, and the default prop is default text of big button, exports the button. So even though nothing's specified by here, when we call this component, it just uses the default text. In app.js, give button the text attribute with the value of an empty string. So your new prop should override the default, making the button element empty once again. Amazing. Okay, review that completes our lesson on props. Here are some of the skills that you've learned. Passing a prop by giving an attribute to a component instance, accessing a passed in prop via props.prop name, displaying a prop, using a prop to make decisions about what to display, defining an event handler in a function component, passing an event handler as a prop, receiving a prop event handler and attaching it to an event listener, naming event handlers and event handler attributes according to a prop convention, accessing props.children, assigning default values to props. That's a lot. Don't worry if it's all a bit of a blur. Instructions for further practice: consider the following challenge. Create a simple online grocery store with reusable React function components. Your store should provide users. All right, I'm sure that this would be great to do. I've been sitting here for quite a while, and at this point, I do think I'd benefit from going to the gym. React Developer Tools. It's so frustrating because I'm so close to the end. I guess what I'll do is I'll read this, and then I'll call that the session. So, React Developer Tools. Use React Developer Tools to debug your React applications. Effectively debugging applications is a cornerstone of programming. After creating a React app, an important next step is setting up your environment to debug it. We'll cover the basics in this article using the initial skeleton created by using Create React App. This article assumes you are familiar with Create React App and Chrome DevTools. We're also going to be briefly touching on state and props within a component, so it's best if you have a basic understanding of these concepts before proceeding with this article. We've included this article in video form too. You can watch here or scroll down to keep reading. 1. Install React Developer Tools. Facebook created a Chrome extension to help with debugging React apps. It is called React Developer Tools and allows developers to inspect React components, view their properties, and interact with them while looking at the application in Google Chrome. You can add this functionality to Chrome by navigating to the extension page here, selecting Add to Chrome, and following the installation prompts. So, Add to Chrome, Add extension. Great. So, back here, inspect React components. With the extension installed, if you start your React app, npm start, and visit the site in Chrome, the React Developer Tools icon in the Chrome menu bar should change from inactive to active. So let's see. Bring this over here. So we'll put this right next to it and rerun that. Extensions. Things are getting a little strange. See, I'm not using Chrome, I'm using Arc, but it's built on Chromium. And there's got to be a way to access my extensions. React Developer Tools. This page is using the development build of React. Note that the development build is not suitable for production. Make sure you use the production build before deployment. Open the Developer Tools, and Components and Profiler tabs will appear on the right. Okay. So open the Developer Tools. Components and Profiler tabs will appear on the right. How to open the Developer Tools from here. Split view options. Toggle console. How do I open the Developer Tools? Developer Tools. Okay, same place I was. So, from inactive. If you start your React app and visit the site in Chrome, the React Developer Tools icon on the Chrome menu bar should change from inactive to active. This indicates that the site you are browsing is React app in the development build. When a page is using a production build of React, the icon will look like this. To open the React Developer Tools, first open Chrome DevTools, view Developer Tools. On the same banner as elements, sources, console, etc., there will be two new React tabs. Component, so same banner as elements, sources, and console. Components and profiler. These two tabs will only appear on sites using React. If they're not visible, you'll need to click on the arrow to expand the tab section. Click on the Components tab. Right now, all we can see is app itself, but we want to see the contents of app as well. In the above image, you'll see that the cursor is pointing to a gear icon. Click the gear icon to open up the settings, and then click the Components tab in the pop-up window. By default, there is a filter that is causing the host document object model nodes to be hidden. Delete this filter for now, and then exit out of the settings window. So, where's this filter? Delete this, and then exit out of the settings window. You can always go back into settings and apply your preferred filters. Now you will see a tree of apps contents as you hover over the elements on the left. They are highlighted in the rendered view, similar to Chrome DevTools. If you click on the elements on the left side of the window, their properties are exposed on the right side. It's props alt logo, class name app logo, source from here, rendered by app. If your Chrome DevTools appear vertically on the left-right side of the window, app and its contents will appear on top, and their properties will be exposed underneath. You can also use the search bar to locate elements by name. If you've played around with React Developer Tools before, you may notice that this looks a bit different than what you remember. If that's the case, you may want to take a look at the official React documentation for what's changed, or how to get the old version back if you're more comfortable with that. Modify components with JavaScript. With React Developer Tools and the console, it is possible to modify rendered React components. This allows you to experiment with changing component values, calling methods, and testing the interaction between components. You can access and update a component's state and props inside the Components tab. Click and edit the props and state from the right side. For state to show up, you'll first need to initialize the component with some state from inside your files. So, click and edit the props and state from the right side. For state to show up, you first need to initialize the component with some state from inside your files. So if we go to app, props, works with React hooks too. You can also do this. So I don't know, what if, hello? I know that we have this header here, which we can, as these children. There's a P. Hello world. Works with React hooks too. You can also do this by selecting the component, switching over to the console view and accessing the component by logging $R. By logging $R, you could see that this was indeed the component selected. With these tools, you're now ready to begin debugging React apps. For more details and practice on how to use the updated tools, check out this interactive tutorial. So upgrade to get more. I'm skipping this for now and close this out for now. Cody Overflow Forum. In this project, we will build the beginnings of a web forum. Forum is an online discussion board where users can exchange their opinions on a variety of topics. The most important component of a forum is the comment section. This is what we'll work on in this project. In building this application, you will sharpen your skills in React components by practicing using props, as well as defining, rendering, and referencing components. If you get stuck during this project or would like to see an experienced developer work through it, click Get Unstuck to see a project walkthrough video. So, I think I'd like to skip this, but it's not gonna, oh, okay, great. So you've successfully completed the Learn React Introduction course. You've learned how to explain front-end frameworks, learned basic React syntax, including JSX, create React components, and made them interact together. Your learning journey into React isn't over yet. Here's our roadmap to mastering React. So next up would be lifecycle methods, hooks, state management, and additional basics. Once again, congratulations. Thank you. So, I don't know how many hours I've been at this. It's going quite some time. Where's my OBS? Yeah. So, a lot to learn. But I feel like I could look at something now and kind of understand what's happening. So that's good. I am drained, so I'm